Okay, welcome everyone. Thank you for coming into this room. I'm going to try and kick us off on time. So it's now 1400 and we'll start. Are there any housekeeping messages that need to be done from the venue or the organizing point perspective? Okay. Thank you very much. So welcome to this session organized by CODATA, which is the Committee on Data of the International Science Council, on data policy and skills in a rapidly changing world. So here's the program. Hopefully you've seen that on the Global Knowledge Dialogue website. We'll have two parts, of course, of this session, with a break in between. In a moment, I'm going to introduce the CODATA president, Mercé Crosas, who will give a longer talk on major developments and challenges for data and science in a rapidly changing world, and covering some of the major changes that we face, the challenges and opportunities that we face, and I'm sure that you'll recognize a number of those themes. But it'll be great to hear from Mercé about those issues, as she's working very much at the cutting edge. We'll have discussion and feedback, and then a break, an opportunity for coffee, etc. And then we'll have 4 shorter presentations from members of the CODATA Executive Committee, officers and participants in the CODATA community. So among the themes that will come through in what Mercé has to say include what's the policy response. So I'll give a short presentation on that. It includes how do particular disciplines respond. So we'll hear from Richard Hartshorn, who's the former Secretary General of IUPAC and a CODATA Vice President, on how chemistry, the challenges that chemistry faces and how chemistry is responding. We'll also hear from Steve McEachern, who's the Director of the UK Data Service and also a CODATA officer, and he'll talk about the response in the social sciences. And then we'll hear from Shaili Gandhi, who is an ISC Fellow and has been one of the leading lights in the CODATA early career activities. And she will tell us and discuss with us the response from the perspective of skills and data skills for scientists to respond to these challenges and opportunities. And then we'd like to have discussion in group. As we're 20 people in the room, I think that would be hopefully useful, but we'll see how that goes. All right, so that's the menu. I hope you'll find that interesting and useful to engage with these issues. And without further ado, I'm going to introduce Mercé Crosas, who's the head of computational social sciences at the Barcelona Supercomputing Center and also the CODATA president. Over to you, Mercé. So, clicker
okay.
and mic.
Thank you, Simon, and thanks everybody for being here. Yes, as Simon mentioned, I have the chance, besides being president of CODATA, to work day to day on scientific issues that are very cutting edge, that are pioneering science in computational social sciences, which involves AI and massive data sets. Let's see if I go. So I will structure my talk in 2 main areas. One is that what's happening in science and with data in this very rapidly changing world are two. I think they come from 2 big components. One is the fact that science is more interdisciplinary than ever, and the challenges that we need to work on and with science are more interdisciplinary, this interdisciplinarity, and also that the data and the input to work on scientific challenges require also many times a collaboration between academia, governments, and technologies or industry, right, businesses. So that's one part of the talk. And the other part, as all of you, now becomes part of almost any conference in science or in industry, is that AI is also changing a lot how we do science, and how we learn about the world around us, right? And it has a lot of potentials for helping scientific discovery, but also there are obviously there are some issues and concerns about it. And with that also the fact that it's not only that AI is more used, but also that we have more data, or at least the potential of using a lot more data for scientific inquiry. So first, the part about the interdisciplinarity and collaboration across sectors. So there are several studies. I'll just put a couple of examples. I think all of you know that it is true that science becomes more interdisciplinary, but it's also important sometimes to understand it from a scientific point of view. That is it really doing an impact? What kind of impact is this interdisciplinarity is doing to science? So one of the studies done around this topic shows that even adding one more discipline to a study, to a scientific study, it already increases the impact of the science that you produce by a 20%, right? So that's one important point. The other important point, as another example, is that when we look at the map of science, sometimes, well, in the past, sometimes we had not included social sciences and humanities as much into part of this scientific enterprise, right? As if they are not part of the science, but that science is about how we learn about something, right? It's about the methods and the process, not about the material, the topic that you're learning about. So you can learn about humanities, about human behavior, about any social sciences with science, and some of these maps of science that include that look at a very large data sets of how researchers click on data, how they go into publications and information about science. It includes, well, it shows you can. I realize it's hard to read this very large map, but it shows that social science and humanities are part of this map of science. So that's another thing, that it's very interdisciplinary, and it includes disciplines that maybe were not included in science before. The other thing is ISC has recognized and understands very well. It's just that it's also important to fund, to promote projects that include this interdisciplinarity as part of the key part of the project, right? Having that collaboration across, it goes beyond interdisciplinarity in some ways. Is beyond disciplines of different sciences, but it's very important to have the collaboration of many entities and many sectors working together. Salvatore Arco, the director of ISC, said in these science missions, which I believe tomorrow are going to be announced, which science missions projects were awarded. So he said that the myriad issues stemming from unsustainable development necessitate collaboration among the scientific community, the funders, the policymakers, right, tech firms, and philanthropies. So, and these kind of projects and initiatives from ISC promote that. Also, in Canada, well, they could give several examples. This is an example in Canada how internships and collaborations that go across academia and industry, right, have grown very much since, in the last decade or so. And again, it includes those internships are not only about the natural sciences, the applied sciences, the engineering, but also about social sciences and humanities. So students, practitioners of social sciences that can have internships in industry or in government. And these kind of collaborations also have grown and become important for science and for the skills, how we prepare, as a method of how we prepare the next, researchers or policymakers. There have been other initiatives in the last decade or so. This one is from originated at Harvard University while I was there, also working on quantitative social sciences issues and research data management. So at that point, we started an initiative that was to do data partnerships between academia and industry. Sometimes it was also partnerships with academia, industry, and government. And in this case, though, we learned how difficult it is to do that. Well, for example, for one of the first use cases was to use data from Facebook, from the digital platforms, right, the social media platforms that we know that contain a lot of information that could help us understand human behavior or impact in democracies, in governments, and so and it just owned this information, but it was very hard to make those partnerships work. It did succeed for a few projects, but it's difficult to. It's one of the challenges that to build those partnerships, right, with industry. You have to find incentives from both sides and make it work. And then, well, just a summary for this part of the talk about this working with data from industry, government, and academia, and collaborating across disciplines. So, as I said, one of the ways that in practice we can make it work is through these partnerships, these strong collaborations. But as I said, I repeat that it is. In theory is a good way to go. In practice, is difficult, so it does take some time to build the trust and for these partnerships. There is also ways of helping to build the collaborations or at least opportunities or ways to access data from companies, from big tech, from industry for research, which is through regulations, through policies. We'll talk more about policies in this session, right? And examples from the European Union, for example, is some of you might know about the Service Digital Act, the Digital Service Act, where it states that researchers should be able to have access to the data from social media and from other digital platforms in order to do scientific research in human behavior. Obviously, with all the concerns or the steps that one has to put in the protocols and regulations that one needs to put for personal data, for sensitive data, right? I mean, the data needs to be anonymized, needs to be taken care and handled in a responsible way. But so the DSA is an example of that. There is also another example are data donations that individuals, right, citizens can do that are data that maybe the companies are collecting about them, but they can, through the Data Governance Act, they can donate for research. I mean, this is done more in health, right? That sometimes the citizens, individuals can give that data to cure a disease, to cure cancer, and so we've seen these data donations tools in the health and biomedicine world. We've seen it less in the social sciences and data policy making world, right? But it is also another thing that it's been done specifically for digital platforms like social media platforms or web tracking data or social media data that individuals give for research. So I missed here that also another important part that there are some initiatives, including some of the work that we're doing, for example, at the Barcelona Supercomputing Center, is processes that help automate also and make more efficient that access to data from industry and for research in general, or from government. So the other part that everybody talks about, and obviously is it is a reality now, is that now we're doing science with more data, more AI, right? We're using a lot more AI for inference, to learn about, to accelerate scientific discovery. So this has been a very rapid increase, but there are also, with that, there are also data challenges that that require policies and also change of skills, as we will talk in this session. So first, just a very high-level summary about the concepts of the taxonomy of AI, basically, that we can talk about. AI, I mean, AI is not only ChatGPT, as you know, right? It's not only large language models. It is we can describe or classify AI in two big blocks. One that it's more data-driven, right? That it's data-hungry, and it needs a lot of data, but there is less expert knowledge. And the other, another AI that is more expert knowledge, that is more rule-based, and you can do, for example, help with a diagnostic of a disease, right? And you have a lot of information about what that diagnostic, from experts, right, about what that would take, and you're building your application, the AI application, based on that. But I'm more interested now in the one that is more data hungry, because this is really the one that has increased in the last few, even 3 years. I mean, already in the last decades, 2 decades, but even more. I mean, it started with the machine learning tools that were built for not only for science, but for industry. Then every time more and more, there was the use of deep learning, right, of the neural networks that needed even more data and had less expert knowledge to predict what would be that would come out of it. And then just more recently, in the last couple of years, with the transformers technology, the large language models have created ChatGPTs or Llamas or Mistrals or other large language models that have generative, that are doing generative AI, right? So those need more and more and more data to pre-train those models. So as we go down here, we increase the amount of data, but we also could increase the results are less trustworthy, or that it's harder to know more, they are less rigorous, or they have less expertise knowledge, right? So here there are also examples of studies that look at how AI has increased in science. And in this paper that is actually called Oil or Water. So that looks at the AI within, the persistence or the growth of AI within different scientific fields. Overall, it increases in all the fields. Here in this plot, I mean, you can look at that paper that is open, it's open access and has all this information, because it's hard probably to read from here. But it shows pretty much that in every field there's been this increase of the use of AI. And when we talk about the use of AI here, again, it's not necessarily just the use of ChatGPT, but it's the use of machine learning tools, right? Deep learning for either classifying, topic modeling, for very different types of inquiry, scientific inquiry, and this has got into every discipline, even though probably when we look at it in detail for some disciplines has had more impact than others, right? But that's quite big, that in every discipline, across all disciplines, including social science and humanities, AI is part now of the research inquiry. So the future of AI in science is probably more of there could be other views. This is one view that includes my view, but it's from teams of expert teams that I have been part of, recommending AI, the future of what do we need to prepare for the future of AI in science. So one thing is the LLMs, these large language models that are very general purpose, right? But they also come with problems like hallucinations and errors that can be made, and they might have biases in the data. The other things are solutions, AI solutions like AlphaFold, that some of you might know because the Nobel Prizes last year, there are 2 Nobel Prizes, right, that connected to AI, and there was one, connected to AlphaFold. Which is a tool that generates protein structures, but this is more of a specific medium-sized AI. It doesn't need the amounts of compute and the amounts of data that an LLM, general purpose, would need. But it needs good quality data. It needs well-curated data. And in fact, because since 1970s, there was a repository for protein structures, the Protein Data Bank, right? Was it possible then to create AlphaFold? So there could be more foundation models for science that are based on are medium-sized and more specific, that need well-curated data, and we will talk more about what that means, what it means when we need to create a repository with well-curated data, right? Sorry, so another point, that the other way of using AI in the context of science and knowledge is to have AI in the loop, meaning that for some of your creative thinking, you could have interactions between AI, generative AI, and humans try to come up with new ideas, for example, or you can do some what would be experiments or some analysis that you would do, for example, again in the field of social sciences, by having the generative AI being basically the respondent, the human that you interact with in that experiment, right? But those things have to be done very rigorously, and being very careful about the data that you feed into those AI models, or that you fine-tune how you fine-tune these AI models, right? You train them more. So here's an example that I'm not going to go into details of but it's again a paper that it's open access that you could look into, that you could how you could use AI in the loop for this creative problem solving. And there is also here another paper as an example of how you use all the potential of using generative AI for social science experiments and for social science analysis. And Chris Bale, who is working a lot and collaborating on projects related to this, to improve social sciences with this type of experiments, says in this paper that generative AI has the potential to improve survey research, online experiments, automated content analysis, agent-based models, and other techniques commonly used to study human behavior. But very important, bias in the data used to train these tools can negatively impact social science research. So we need to think of both. So how I'm doing with time? And I'll have some sort. Okay, so I'll start summarizing some of the data challenges to lead to the discussion after this talk. But so yes, the first, for everything that I exposed about these changes that are happening in this rapid changing world, right? One in the area of more interdisciplinarity and more sectors being part of the science enterprise, and the collaborations that we need to build. So what are the summary of challenges and opportunities related to data in this context? Is just first that if we want to, if we're generating or using data that are going to be used also by other disciplines or by other teams, right, by other groups, because we need to collaborate more. We need to describe those data sets as if were not for us, but they were for others, right? And that requires, using some standards that will be cross-domain interoperables, right? And that leads to some of the work that CODATA works on related to the FAIR principles of findable, accessible, interoperable, and reusable data, and also the cross-domain interoperable framework. We'll talk more about that, but just to see the importance of this if we're gonna do collaborations and interdisciplinarity across for data that comes from different sources. The other thing is that with these collaborations across academia, governments, and industry, there is the licensing, the data agreements that are needed, the protocols, and all the terms of use of the data, right, need to be described in a way that it's commonly understood, that it's a standard. These are one of the examples is the ODRL as a standard to help with that, and that's also part of this cross-domain interoperability framework that CODATA works with, and is making many advances with the use cases. But then the other part is that that we need to be aware that if we're working on the areas of health and social sciences, right? Sensitive data is an issue. We need to take it very seriously. Again, European has some regulations like the GDPR on that, but still they are very useful for research, for advancing, for our data that will help to also cure diseases, that could help to improve organizations and understanding better human behavior. But to do that, we need to use tools, the right methods to work with, so that the data is kept private and anonymous, and so, but we can still use it, right? There are methods like differential privacy that can help with that. So, and then some of the challenges in the context of the use of AI and the use of large data sets for AI are first, like I said in my talk, that in order to do new foundation models for science that require specialized, well-curated data, we need to work on standards and metadata standards that describe well that data, so that we understand the data doesn't have, is comprehensive, doesn't have biases. And so there are initiatives like Crossan that helps as a new metadata standard for AI data sets, basically for AI-ready data, for training data sets, and the kind of standards are also important to be part of our skills, right? And then the use of generative AI for either these kind of social science experiments, or for other, problem solving, basically, needs to be done. Understanding that science needs to continue being transparent, right, with open science principles, reproducible and rigorous, right? And that requires, on one hand, open data, right? Understanding at least what data goes in, at least the metadata that goes in of all the data sets that go into pre-training these generative AI models. And the other thing is that the algorithm needs to be explainable, right? We need to understand what happens to get that inference. And the explainability is some field that in computer sciences work now a lot, and to look at explainability of generative AI as one of the challenges that we have. But here we can go from generative AI models like ChatGPT that would be the close, even though it's OpenAI, are the closest to some like Llama that might have well, some of the code is open, but the data is still not open. From others that, for example, that we're developing for Spain, that both the data and there is a commitment for both the data and the algorithms to be open. So there is a whole degree of generative AI that involve, that go from closer to more open. And those are going to be also important, how the metadata to describe the data set that go into this generative AI, and how we understand the problems that can cause if we don't know what a Gen AI is doing. So just a summary as an introduction of the rest of the session, of today's session. What we need to be ready, right, in this rapid changing world. For one thing are the policies to make all the issues that are talked about work, right? Be more have more interdisciplinarity, collaborations across sectors, better use of AI, responsible AI, and so we need the skills, right? That we'll talk about today too, about to be ready for this increase of use of data and AI. With the tools and a standard for this cross-disciplinary work. And then at the same time, this doesn't work. There is not one solution for all. So we need to see that different disciplines and scientific domains will need to adapt to changes that some might have foundation models that have some issues. Some might have sensitive data issues, and some might have other very, very large data sets, huge, like an astronomy, the new observations that are being done, issues. So for every discipline in a scientific domain, there will be an adaptation of these changes that are going on in science and in the pursuit of knowledge. So thank you. I guess Simon, we can move on. I don't know if there are questions specific now for this talk. We can move on, and we have many discussions too.
Yeah.
So that
can
will
you
allow
click
us.
the next?
Yes.
Yeah. Okay. So what we would like to do now is to give you an opportunity to ask questions or to discuss the issues that Mercé has raised. So what we would like you to think about is Mercé has presented this situation of rapid and very immediate transformations in science, largely because of the use of AI. You saw those graphs or those diagrams of the use of AI in different disciplines. And sometimes we say, or it is said, sometimes we hear, oh, AI will sort out some of the data issues, but this is really a complete myth. And I hope one of the messages that you take from Mercé's presentation is that AI requires data, it requires huge amounts of data, and it requires those data to be high quality and well described. And so we have a challenge in this changing world with AI and the need for high quality data. How do we respond in different disciplines? And so that's what we'd like to hear from you. What are your responses to Mercé's presentation? How are this changing environment of data and AI affecting the research that you do and that your colleagues do? And how do we respond? We've identified policy, training, and the responses in particular disciplines. How do you respond in your disciplines? And do you have any questions for Mercé on the basis of that presentation? Oh. Thanks.
Hi, I'm Dr. Umar from University of Bremen. My question is, when we are talking about AI data modeling and all these things, in social sciences, how we can improve the authenticity of the data? Because without in social sciences, when we are talking about the human behavior and other things, so how someone can be ensured about the authenticity of the data on which the AI model is predicting?
So, meaning if what you're using is just any data from the web, or it depends on what the yeah. If
Usually from primary source and secondary source, we combine data for the prediction and modeling basis, especially, for example, we are talking about economics and financial forecasting.
okay,
So there are multiple sources of that data. But
Right.
the question is how we can ensure the authenticity of that data, because otherwise it will be garbage in and garbage out.
Right. But so I think it's not just one answer; it's several things, right? And maybe in some of the discussions that will be part of this session, we will talk more about that. But for one thing is that if what you're doing is using as the in, I mean, any basically neural network, you could think of it as there is something comes in and there is something comes out, right? And something goes in the middle. That's the basic definition of a neural network. So the in, if it's part of data repositories, right, that or databases that have been, you know already that they have been curated, there is some trust in that data because it's from a source that is a trusted source. You already have some level of authenticity. It depends what you mean here. Also, the data being authentic. I mean, it's been collected. If the data that is in this that you're using comes from the repositories and you have the metadata and the code books and the information that the documentation that tells you how it is being collected and what are if there is missing data, is it representative of what you want to study, right? So that by itself, that we think of data quality, to me, is part of the authenticity, right? Authenticity. And now I cannot say the word. You're easy. So that's a big part of it that you. That's why we put so much emphasis of how we describe the data that we're using in terms of what it's being collected, what it represents, what it is included and what it doesn't. It doesn't have to be perfect. I don't think that there is a lot of the data about human behavior that, of course, is missing information, but at least to understand in what way is biased, if it is, right? So that you can take that into account in your analysis. The same if what you're using is just social media data. It depends on what you want to study. That if you're using data from platforms to study social behavior, you're understanding social behavior in the digital world, not the day-to-day social behavior, because that the data from the platforms doesn't represent necessarily that, or maybe you can infer that, but then you need to be careful. So I think it's a combination of how well described the data that you're using is, so that you know, right, how valid it is, and also that are you using the right data for the right purpose.
Okay, thank you very much.
I was wondering even whether Steve might additionally want to come in on this point as director of the UK Data Service. How do you deal with data quality in the sets data
Yes, you can go
services
more specific than me about that.
Yeah, I mean, I'll talk a little bit more about this later. But I mean, essentially, we deal with essentially thinking of fitness for use. I think my question to you back would be, what do you mean by authentic here? Because depending on what you want to do, any or all of the above can be authentic. So we focus on fitness for use. Is it sufficiently described, as Mercedes says, in such a way that you can make decisions about, do you think it's authentic for what you need to do?
My question was backed by the case of Cambridge Analytica. So in social sciences, it's really difficult to predict the behavior, especially. So when we are getting data from the secondary sources, so most of the time the data is biased. It's not a true reflective of what human behaviors are thinking. So I think I'm wrong enough. So that's why I had always concern when using AI and directly people are putting data into it without
Right.
authenticity.
Yeah, I mean, so I think for this at the end also what it is important to when you're using this the AI for a study, well, as part of what an analysis for social behavior or social studies, right? You need to make sure you can validate it first, and that you have trained that AI to do the task that you need, the analysis task, and so by validating it against something else, you have to have what is your benchmark, right? That you're comparing into that helps you to see the data that it is being used in this AI, it's giving you the right response compared to a benchmark you have. And then you start from that, and then you can do inference. That's usually the process that you would have to build. I'm sure you know the challenges, but it is being used successfully if you do the process of using a pre-trained AI model. You train it, you validate it for your specific, like Steve says, for your specific purpose, right? And if you have validated that works, then the data could have had some biases to start with, but you have in the fine-tuning, in the training, you have improved that until you validate it against a benchmark that you're comfortable with, that you think that's authentic in the context that you're saying authentic. Yes.
Thanks, Mesa. We had a whole load of hands go up there, so we'll this gentleman here, please.
Hello, thank you. My name is Hugo Hidalgo from the National Academy of Science of Costa Rica, and I have a question that is related to that. I was wondering if AI has biases and errors. People consult and use massively this data and then put documents into the web also based on these errors, and later future models fits into errors,
yeah.
and this propagate forward.
Let me first just, I mean, I said that in the talk, but I just gonna repeat it just to make sure, because the AI, the scope of AI is very wide, right? And we're talking here, you might be concerned about the generative AI from like a ChatGPT type of AI, right? Which is different. That what I promote, what I think is the future of AI in science is not necessarily only this. I mean, this can be part of it, the generative AI, but are also foundation models that are not biased, because you have fed only the data that, like the AlphaFold had only protein structure data, right? It had only the data that it needed to then create new proteins. So you can do that. Just separating, because when we say AI is very, we talk about many things, and at least when I say AI, I talk about many things. So yes, for some cases you can take care of the bias because you only pre-train that model with the data that is good quality, that you know that fits your purpose, right, for what that model we want to do. If what you're going to do is something like an LLM like ChatGPT or others, that's why I say the importance of openness of that LLM. I mean, I don't say not to use them, but I think the more open it is, the more we know what went into it. It doesn't mean we cannot use it, but if some data that went into is not the one you're interested, but at least you know, you have a better understanding of what goes into and how it could be biased for your what you want to do. And then the last thing is that if you're using a Gen AI tool, right, a generative AI like an LLM, we know, now I repeat it several times to probably everybody understands when I say Gen AI is equal to LLM at this point, large language models, although it could be multimodal models too, but we're not going to get into that. Now, and one example is ChatGPT, but there are others, obviously, right? So when we're using one of those, and we are concerned that they has feed data that might be disinformation or misinformation or bad quality data that went into that. I mean, again, it depends what purpose do we use it for. We have to do this fine-tuning, this training of the pre-trained model to really for the task that you want and validate it and do the process of validating the results to see that is that bias in the data. I mean, can you change the bias in the data by training it with the data that you want, right? It's like an additional training to the initial training. And can I then validate it against a benchmark to see that there is no bias? I think that for us, the important thing is to know that there can be bias. So then let's do all these processes in a rigorous way. Let's try to make them as open as possible so we know what goes in, right? And all that together. And of course, it's a constant fight because there will be more probably more information generated from AI that could be not valid. So we need to continue. It's a continuous task.
Thank you.
Thank you very much. So I see lots more hands going over. We have a gentleman here. I think next, Charlie, was Christopher, and then we have 2 hands up here. Please ask your question.
Yeah.
Okay, my question. Okay, thank you for your very interesting this presentation. My name is Professor Demberel. I am from Mongolian Academy of Sciences, and I have 2 questions. Okay, it's more related with data policy. Okay, IA, it's becoming a big business in the world. Okay,
Yes.
Business people, business companies, IT companies is developing this sector very quickly. And big data, what is big data? Big quality data usually in academic institutions. Okay, you have in your country big relationship, big partnership between this business sector and academic institution.
Mm-hmm.
Okay, it's I just would like to say Jewish saying. It's my friend just before to come here told me this. Where is your money if you're so wise person? Okay, it means about scientific people. It's I mean, if we have this big data, quality data, and this artificial intelligence is developing so quickly, and we are giving data we are talking about open science, we are contributing data, but business sector is doing business. We are remaining as before with empty pocket. Okay, this is the first question. What do you think about it? And another question is related with today's situation in the world. A few years ago, everybody was talking about globalization. Okay, it's we should work together, but now the situation in the world is changed. Now we are talking about localization. It's not given data. And what do you think about new challenges and difficulties of open science regarding this situation?
Okay.
You want to
Right.
take some of the questions, and
Yeah.
I can add to it too.
Yes,
But
yeah.
since
I mean, so
you work more,
the first question, if I understood it correctly, was about the resourcing of science and the resourcing of AI in science when there is so much money going into AI in other spheres. I don't think there is an easy answer to that, but there will be resourcing for incredibly successful uses of AI like AlphaFold, like other uses of AI for identifying early occurrences of cancer. So in those particular areas where there are very specific uses of AI in science, there will be resourcing because there are such important cases. For the second question about, we were in a world of globalization and international collaboration, and we're now in a world of, shall we say, increasing geopolitical tensions. All I can say is a very general appeal to scientists to collaborate. Science is global. If there's one thing that all countries need, and that humanity as a whole needs, and the planet as a whole needs, it's science. And you know, I know that sounds a little bit like motherhood and apple pie, if you follow that expression. But I think that's why we have a global knowledge dialogue, and I'm not sure that we can say a lot more than that.
Right. I mean, we don't give up on open science, even though there are other issues, and that not everybody will will walk the same way, but I think that if we build the type of AI that is open and responsible, I think we're going to do science better with it. And at the end, the impact will be more.
We had a lot of hands
Yeah.
up, so I'm going to pass
Yeah.
over.
Yeah, I think
By the way,
there was-
everyone in Mongolia had a very good news this morning, yes? So who was our next question? Christopher.
And there is a question here too, right? Yeah.
Thank you, Simon, and thank you, ma'am, for your wonderful presentation. My name is Christopher Zhu, and I'm a young climate scientist at Imperial College London, and also chairing CoData Connect, which is the CoData Committee for Early Research. Yeah, yeah, and I'm thank you.
Congratulations on your work on that.
Oh, thank you. I'm really happy to be here representing the younger generation of scientists. And I have two very brief questions. As a climate scientist, I understand like the climate change is definitely widely recognized as one of the major challenges of our age. So is there any new opportunities, or what should we focus on? Like how AI could produce more like useful information for the reduction and control of natural disasters, such as natural disasters and other mitigation aspects of climate change. And second question, I would like to know more, like how is CoData's mission to support younger generation of scientists and widely more early career researchers? Thank you.
Yes, and I'll answer the first, and maybe we can think of the second, because there is a discussion later that might be so since there are other discussions, might be more relevant to your second question. I mean, the first one, I think, and you might be aware of, but there are many examples. I have closer examples near me because I'm in the Barcelona Supercomputing Center, which happens to have a whole department, scientific department on earth sciences that work on climate change. They've been in the last decades working mostly on simulations that are more, with Navestock's simulation of the climate, so the atmosphere changes, right? But those are, we consider more classical. Now they're putting a lot of effort also to introducing AI for a lot of the predictability, not only climate change predictability, I mean, just in general, but yes, of mitigating and adapting to specific events. So it's just part of the everyday work right now to use AI in this context. But I don't know if you want to, you're thinking of specific examples, but within these, the European, well, there is, for example, the Climate Digital Twin, European Digital Twin, that is doing the entire, looking at the entire, changes of climate in the world, but doing a full digital twin of the Earth, basically. There is also some digital twins of the oceans and the impact of the oceans, but those are a lot, there is a lot of AI that goes into that. Again, talking about AI in a very broad ways, not only generative AI, but also some of the machine learning tools, methods that have been used in the last decade or so. Yeah.
And for the question about activity, what is needed for young scientists and what is CoData doing, Shaili will say a little bit about that in her presentation. Well, I was just going to say in her presentation, I'll just say that in 2024, we collaborated on training activities for data scientists and for scientists using data in Pretoria, in Ulaanbaatar, in Beijing, in Mombasa, and elsewhere. I can't remember the other one. But so we've been doing a lot of activity as CoData on training in data skills. And the participation of Shaili and Christopher in our activities shows our commitment, I think, to early career scientists. We have a question from here next, and then I'll
Thank you,
back.
Doctor, for speaking. And Dr. Khalid Rai, I am worrying about that, like the data missing for the scientists sometimes, and how we can trust the AI for the researching have been done sometimes like from A to Z has been done from the AI. So how we can deal it is like we trust that data we have been received and how we pass it away for the others, please. Thank you.
Okay, so the data missing in general for science, I mean, again, we have now in the 21st century more data than ever science has had before. At the same time, there is a lot of data that are more in the hands of well, industry, big tech, or governments that could be useful for science and that cannot be used. So I think that part of this is not so much that the data are missing in the sense that doesn't exist at all. I mean, in some cases, maybe, yeah, we should be collecting more data, but a lot of the times there is a lot of data collection from private companies, right, that could be used for science. And that's why I emphasize on the need of this type of partnerships and regulations and policies that help use this type of data when you have a scientific challenge that would provide a good impact to society, right? That resolving this would provide a good impact to society. And in this case, so building those collaborations and the policies that help you with that, and of course building the standards that would help to access that data, reuse that data, I think is what you need for that missing data that actually exists, right? And it requires this trust, building that trust. In terms of the AI, I mean, maybe I don't want to be too repetitive, but I think that every time we think of this, how we will trust what comes out, the data comes out of AI or the data that we use for AI. What I think that what we need to remove from our minds, I think, is that we just use an AI tool like ChatGPT to answer a question and we just trust that. That's not science. We cannot do that, right? That's not the way, but that's why there are some processes of still using this generative AI, but before validating, training it for the task, for what you want, the type of answers that you want, validating that it actually works for that, and then you can start trusting that. But I mean, it's a continuous learning, right? So you trust it to the point that you have validated and you have retrained it with better data. Yeah.
Okay, so we've got a queue of questions here and then here and then here.
Okay, thank you for the talk. My name is Silvina Ponce Dawson. I am a physicist. I'm president of president of the International Union of Pure and Applied Physics.
Great.
Professor at the University of Buenos Aires.
That's great.
I wanted to ask you about the skills that you were talking about, because I mean, as physicists, it's very common that we write code, but now our students are using AI to write code. So how much, I mean, and also it's changing what we mean by understanding, because I mean, now it's like you get a lot of data and work like with a black box and get some answer. Yeah. So it's changing also how we approach our object of study. In physics, that's very, I mean, clear. In other disciplines, it's slightly different. Yeah. But now, so the question is, how many of those skills that I guess it's human skills that you're thinking should be trained, you think could be replaced by AI itself? Because I mean, AI can write the code to analyze the data and I mean, like self-generate itself.
Right. So again, we will have more discussion later about specifically about skills, and so I personally don't. I mean, I know that there can be a whole discussion, and I think that it's not easy to have an answer, right? And, but I don't think that in this case, for example, using AI to generate code, I think can be a very useful way of using AI, especially that, I mean, I have a son that does that all the time. He's a computer scientist, and it helps him. But he always says, and the same with the people in my team, right? And they always point out that actually they can validate that it works because they know how to program to start with. So I think that it doesn't remove that you have to still be an expert, and even a better expert to then, I mean, at the end is the what best practices and or policies you make to make sure that it is checked and reviewed and like the same way that I was talking about validating a foundation model, you also need to validate that use of AI for coding, right? But if there is the tools that are AI-based that help you, that you have this human data AI loop, right, that I discussed here briefly, that some studies are looking into that, the best way of collaborating with AI to do this kind of task. And I think the important thing is to not remove the human in that loop, and that human actually has to be even more expert to validate, to help validate that and be able to review it and know that it works or not. Right. So that's I know that at the end we will need to take every use cases that you are discussing and see for this use case what would be the right balance between this human AI interaction, and how do we make sure that, again, if your purpose is to teach students to be good coders, they have to first learn to code. They cannot just do it directly with AI without a. So I think that there are this will depend on what is the purpose of what you want the students to learn, right? But maybe we have more discussion of that after we've heard all the other talks, because I could go on and
we can go back to that question in the second part as well. Now, just in a matter of housekeeping, we have questions lined up. We had planned a 15-minute break now to allow people to grab some water or whatever. I propose, as we have people asking questions, that we go on to 10 past, we have a 5-minute comfort break, and then we start the second part at 1:15. Do we have agreement? Okay. Next
if
question,
anybody
please.
needs to get up, though, get up, please. Yeah, if anybody needs to get up, though, right? I mean, we're not holding you here.
So my question has to do with the
Sorry, please
format.
introduce yourself.
Yes, can I put the setting and then I'll introduce my background to this. So my question really has to do with the format of transferring cross-disciplinary. You know, what is it that you actually want to transfer from one discipline to another, and how do you want to do that? And I think this is always a huge, cross-disciplinary.
Do you mean about data? Are you talking about the context of data or the context of knowledge from one discipline to another?
I'm talking really about the knowledge. The knowledge, and the format of what it is that you want.
How you transfer that?
How you transfer that, and so my background. I'm Diana Worrell. I'm General Secretary of the International Astronomical Union. So my background is astronomy. Now we have huge data sets.
Right.
They're well verified. We have no problems in that area. We have telescopes of increasing.
Yep. In Chile and everywhere. I'm an astrophysicist.
We have people working in that have historically been in different subdisciplines of that. There's been a huge kind of getting standards. And of course, there's a large amount of work in what you call your bottoms-up AI. So, machine learning and all that. So we have all of that. But in order to talk between disciplines, you need to understand what is it of that. I mean, our historical way of transferring knowledge is through publications, and publications in different disciplines are not read by the other disciplines, of course. They're and so there needs to be some way of getting people to transfer, to have a framework for transferring that. And that seems to me fundamental to something that CoData
I think it's a very important question too, that maybe we will.
And needs funding. So.
Yeah, and I think maybe we discuss more that later, right? But I just wanted to add a couple of quick response.
Quick response, and then I'll say from the CoData perspective.
Just also because. Just briefly about my context, because I'm trained as a physicist and PhD in astrophysics, and I was for very long at Harvard Smithsonian Center for Astrophysics, and then in biotech, and then in social sciences. So just as a personal trajectory, I understand that transfer of cross disciplines, and I think that the importance of also creating it's not only just publication. I mean, for one thing, publication should be done in a way that are better understood by others, not in your field, but that's a whole other topic, right? The way scientists write sometimes is too they have the course of knowledge and they don't communicate in a way that others can understand it. But I think that at the end it's more about these teams. I mean, it's part of like what ISC is doing with what is promoting now, building teams that have these people together. Like teams, for example, the team that I built now in the Barcelona Supercomputer is a mix of computer scientists with social scientists, with other, with other disciplines, and working on a problem together. That's the best way of transfer. But since we'll talk more about that later.
Yeah, no, I mean, and I think, Merce as co-data president, one of the things that was fantastic when she was elected, or that we were very pleased about when she was elected, was precisely that personal trajectory and to have worked in so many disciplines. This is where science is going. Co-data is doing and has done a lot of work on interdisciplinary and cross-disciplinary reuse of data. And it's exactly as Merce says, this is happening more and more. Those teams are being put together. And those teams of researchers need to be able to transfer and combine data across what used to be regarded to some extent as hermetic disciplines, and they're not anymore, and they can't be for the science that we need to do. Next question.
Okay. So my name is Diana Roig, and I'm representative of the Young Academy of Spain. I also come from Barcelona. Hello. And I'm a career professor. I work on digital humanities and social cultures and also global literatures. So
we should really talk.
Yes, I know.
We're neighbors.
Yeah. So I want to follow up with the previous question regarding missing data, and I think that there is missing data related to women, knowledge production related to women, related to minoritized communities, or to produce knowledge that was mainly created through an oral tradition. So we don't have data for that. We have very little data, scarce, scattered. So I think that this is really a gap, and not only for talking about the past, but also for talking about the present, and of course, for talking about the future. So how can we deal with these gaps, and how can we avoid that data reinforces the power of those who don't need it, instead of shedding light into those who really need it because they were overshadowed? So I want to point to the bad sides, negative sides, to struggle this data for positive changes well. And this is, we could discuss longer about this. Yeah, thank you very much.
Yeah, no, I'm completely right, and I just apologize because I missed when we, with this question, I thought it was in another context, but if we in this context, we do have that missing data, but we are working on that in CoData.
Yeah. And I'd like to respond to that. There was a book by Christine Borgman, who people in the data world know, a few years ago, which had a wonderful title. Big data, small data, no data. There are so many generalizations made about data on the basis of the experience of a single subject, or almost sometimes a single scientist, or things we hear about in the media. There are some areas of research where there is big data, of course. It's not always the right data. There are some areas of research where there's small data and some of it's incredibly well crafted, but there's not enough of it. And there are some areas of research that we need to remember that there is simply not the data we need to understand the question at hand. In particular, where there is bias or there are underrepresented groups, etc., etc., etc. So that is an area that we absolutely need to address. We'll say a little bit about that in the policy section, but I think the question is too big for us to cover in this session as a whole. It will feature very strongly in the International Data Week conference, which please consider that, and in other work that we do with CoData. Yeah. We have a question here.
Thank you, Professor Abslam Humada from the Moroccan Academy of Science. So I think that to have access for the South, South countries to have access to scientific data. There is a very difficult problem with to be membership at CERN in some experiments, ATLAS, CMS, in astronomy or astrophysics, IPERCA in Japan. And the fees for membership is very high. It's very expensive for the South. And I think that if we have an access to data of these experiments, I worked in ATLAS experiments at CERN since the beginning of ATLAS. I think that also to have some data center for science in Africa, for example, or other countries, it will be very useful for training young students. And the United Nations organization have promulgated the Decade of Science. And I think that during this decade, if we can have some international regulation for data, the scientific data, I said, because we have very good students in mathematics, in physics, in digital science, but they haven't access to improve their competencies in these fields if they want to go further in their... and for social science, there is some subject related to sovereignty, to some political issues. So it is difficult. My experience in Morocco, many surveys, they don't give any response because the subjects related. So they cannot share data about some fields in social science. And thank you for your presentation.
I mean, I think this is very aligned with CODATA mission to be able to promote open data whenever possible, with, of course, understanding, or even better described as fair data, because understanding that it's open as much as possible, but when it has to be restricted for sensitive data, also that, and that there would be this access, right? The findability and accessibility needs to be real in across disciplines and across the world, right? And that's part of our the platform that we run from.
And in the next session, or the next part of this, rather, seeing as we don't have two sessions, just one big one, we'll address that more. This will be the last question, please, and then we'll move on to the next part.
Thank you. I'm Marie-Alexandrine Sick. I am from the climate change community as well. And I have a question in relation to the list of challenges that you showed. And I wonder whether within your community you don't see it as a challenge, the fact of transitioning towards low carbon practices, in particular in the context of open science, which will generate more data exchange, data storage, data use, plus the modeling activities and IA. So I wonder whether you have had this kind of discussion within your community.
Let me make sure that I understand that the open science could generate more data that it's used then for AI, or is that what you mean?
Exchange and users, there will be more users, more exchange of data, more storage, and also all the modeling activities. So, I mean, the activities...
Right. So the challenge, because of the large amounts of data that needs to be handled.
And more users, and the fact that people tend to export the data from the database to their computer.
Right. So, yeah, definitely, there are some a number of challenges that it's true that we didn't go through all the challenges that exist. There are challenges in terms of dealing with more and more data all the time that are more the technology. Some are technical challenges of transferring the data, how we build infrastructures that we can compute in a federated system, for example, that you don't need to transfer the data all the time. So there are things that are being considered, right? For example, in Europe, across the supercomputing centers or the HPC and data centers to do what can be done by federating the data. There are other challenges that are more of sustainable challenges about how do we pay for all that? There are more and more data, right? What do we keep? And so I think it's a whole topic by itself. There are these challenges. I think there are the things that also are of concern to CODATA and we'll work with the communities because each scientific community might be different, the type of, well, based on the amounts of data, how much data they need to keep, what data are useful for, well, for preservation or not, and so on. What are the costs of that? Right? But I think in general, the idea is to build solutions that we don't need to transfer data all the time as much, that we can federate it and can do when you have a massive data sets, you compute it in the computational center that the data exists.
Okay, thank you very much. I am absolutely delighted by the number of questions and the discussion. Thank you very much for your engagement.
Thank you.
It's a pleasure to be in a session where you run over into and through the break because the discussion was going on rather than because the slides were going on. I know we've all been there. So again, really, thank you very much for your engagement.
Thank you very
much. But we should... Yes.
Thank you.
So we would like to move on to the second part. So now we have 4 shorter presentations, and we'll try to keep everyone on time so that we can have the discussion in groups, and we'll say how we'd like you to do that. So we'll...
5 minutes? We do still the 5 minutes?
No, I think we do...
I think we should.
Okay.
Would it be okay, a 5-minute break? Or?
Yes? Okay, 5 minutes break. All right, sorry.
Okay.
Thank you. I was going to ask them to just...
one of them. It's perfume, but I thought it was candy. But I spit it out, so it's really like candy.
I have noted it, right? I wasn't sure what it was.
Yes, yes.
Okay.
I thought it was.
Are you sure it's not poisonous?
I'm sure because I feel alright. It doesn't say what that is.
That was the reason, I just wanted to mention, that was the reason I asked whether or not I knew something from which I joined recently. So what we are doing is we're using AI to generate and annotate the social media data for sentiments. We do the first step, put it in, and then we have an active learning process.
Yeah.
So the outputs from that is reassessed by humans, but
you need some sort of human in the loop.
yes, exactly.
Yeah.
And now
supervised learning.
and now we are working on the next paper. Honestly, like this whole paper business started when I joined in Austria. But, why? And then I'm showing them all the studio publications and everything. What is there on my university website and everything? No, but you need research papers. Well, we do that now. It was funny. So we're working on another paper also to see if AI could help in topic and sentiment analysis, because it's very difficult for a human to do it also.
Well, yeah. I mean, I'd say there's two competing problems. The computers don't understand the abstract, and the humans can't do it at scale.
No, it's crazy because like I went through a few texts and they're like, I don't understand, is it positive, negative, anger, fear, joy, what does it want to say? So we are trying to attempt something and we'll see how successful it is and then publish.
Yeah.
How do you work it out?
I think that's probably the model that we forward of. You're not going to have, it can't be one or the other.
No.
May I introduce myself to you? Oh, my name is Christopher. At the Center for Environmental Policy. And I'm also chairing the UNESCO thing is early career researchers. Oh, you're from Korea? Oh. Yes, we're very yes. I used to get engaged a lot of work with Chinese Canadian science opportunities. Because you usually study in various ways. Yes, I'm
to 2019 for the periodical table year. Yeah, we have that. And this year they can't really highlight it for the I don't know if they are planning to do the for the physics, but they are planning to do the AI light show.
Machine learning and AI and some they help arrange for the subway. The nature disaster.
Richard visited and so we took the subway. With the periodic table and
oh.
activity.
Oh.
That would be a way.
That's why I know.
Yeah, I had a word.
Oh yeah, you
Okay, I'm very sorry to bring things back to order. We'll we'll start the second part. And as I said, 4 presentations. I'm going to talk about some of the policy implications and some of the tools or the building blocks that we have to start preparing a policy response for in relation to the challenges and opportunities that Merce has outlined. We'll have 2 presentations from particular subject areas. As I mentioned, Richard will talk about the chemistry, the challenges in chemistry and how the chemistry community is reacting, and Steve will talk about the same from the perspective of social science. And then Shaili will talk about the issue of training and capacity building and engagement with young scientists. So we'll try to get through all those in an hour, and we might have enough time for some discussion after that. We were going to have discussion in groups. I'm not sure that we're going to have enough time for that. But there were so many questions before that maybe we don't need to divide people into groups. So I'm Simon Hodson, Executive Director of CoData. I think I introduced myself earlier. The framework for a policy response. So I'm going to talk about open science, and in particular the UNESCO recommendation and some features of that. I'm going to talk about the FAIR principles, which we'll see how many, I hope many of you have heard of, briefly about the CARE principles and some of the ethical dimensions that we need to be aware of, and some World Fair recommendations, some recommendations from the World Fair project. And I present this as I said, a framework and the building blocks that we have to prepare a policy response, and to prepare policies for science, and for the use of data in science. These are not finished. These are the things I'm going to mention. We're not pretending that these address all the issues that have been raised, but they do provide us with some of the tools, I think. So, open science. I hope you're all familiar with the idea, in broad strokes, of open science and the importance of the UNESCO recommendation as the first policy instrument at an intergovernmental level to set a framework for open science. I had the privilege to be the co-chair of the expert advisory group that fed into the documentation for that. So the idea of open science, to maximize access to and participation in science and its benefits, and something that the UNESCO recommendation does it stresses a lot participation in science. Science for society, science for the planet, and involvement of citizens, of the public, with scientific creation. And we see that also in the ISC's idea of science missions. Now, open, not completely open as possible, that the outputs of science, code, data, etc., and the findings, the knowledge, as open as possible. But obviously necessary protections. And the recommendation provides a framework for that. But this is an area where more work is needed to be more precise about how we protect what needs to be protected, while again maximizing access to the outputs of science. What the recommendation does very well, I think, is set out a framework of values and principles and an action plan, a list of the things that needs to be done. Now, that's not exhaustive, but I think it mentions the most important issues to create a common understanding, to develop policies for capacity building, for training young scientists and the broader scientific community and the public in the principles of science as such and of open science, and of course the enabling infrastructure. We also in CODATA, this is not a sort of definitive piece of published work, but I think we're increasingly talking about what you might call the R's of science, and in particular the R's of open science. And this is something that Merce has stressed a great deal in the last year or so that she has been president. So why do we need open science? To improve the rigorousness and the reproducibility of science through access to data, code, protocols, etc. How on earth can science be reproducible if we can't access those steps in the scientific process? And above all, the data and the code, I would argue. That science should be responsible and respectful. So those ethical considerations which are part of open science are incumbent upon the scientists in their practice and in their engagement, particularly with human subjects. I'll mention a little bit about that later. Relevant. So one of the ideas of open science in the engagement with society, and indeed of the ISC's idea of science missions, is that science should be relevant. It should aim to improve to create a better world, and it can't do that unless there's genuine engagement with citizens, with the public. And hence that idea of the science missions and of transdisciplinary research and impact-oriented research. And by impact, I don't mean impact factors, I mean impact for society and the planet. And return on investment. A lot of the interest from funders in open science is to increase return on investment. For science to be more efficient because it reuses the resources it creates, and to give the data, the code, the knowledge to wider society, including for-profit companies, to use to advance the economy. And this is certainly in the thinking of a lot of funders, and we can't pretend it isn't. And it is important. So who has heard of the FAIR principles? So a certain number, but not as many as I might have thought. So the FAIR principles were published in an article in 2016. They came out of a workshop that was held in 2014. And they argue that there are sub-principles in a lot of detail. And I'm not going to go, in this context, I'm not going to go into all that detail. But they argue that in order to have maximum utility and maximum benefit, data and code should be findable, accessible, interoperable and reusable. Now, findable, that should be obvious. Accessible under certain clearly defined conditions, because perhaps there's sensitivities. Interoperable means that the data can work together. You can essentially, that the data is commensurable. that you can combine different data sets. And reusable, that should be straightforward. You could download a data set, and there's enough information for you to be able to use it in a scientific context. Now, the article that published the FAIR principles has been incredibly influential. Even by inaccurate or insufficient metrics of citations, those are pretty significant. 6,500 citations according to Nature, where it was published. Over 15,000 if you ask Google Scholar. Why the diversity? I don't know. That would need to be, we would need to examine that data, as always. But it encompasses in an easy communicatable acronym some important principles for how you look after data and give it maximum utility. Above all, there's an emphasis as well on the machine actionability of data. This information that you attach to the data makes it usable by machines as well as by humans. And it increases the value of data and the reuse value of data for the economy. And there's a PwC study which looked at the opportunity cost in Europe of not having fair data, because the data wasn't being used and reused and didn't have its maximum value for scientific reuse, which they estimated at, that figure is wrong actually, it's 10.2 billion. They discussed the two figures and then side on the side of 10.2. And just a mention of co-data engagement with the FAIR principles. Our current president, Messe, who's in the room, and Barend were both in the workshop and co-authors of the article. And I was the chair of the European Commission's report, Turning FAIR into Reality, which set out a roadmap for how we implement the FAIR principles in the European research area. Now, as an adjunct to the FAIR principles, we also need to think in terms of ethics and in terms of those access to data and participation of communities that are marginalized. One example of that are the CARE principles. Now, I'm not going to go through this in detail, but we should be aware of that. They feature very heavily in the UNESCO recommendation, for example. So the FAIR principles for governance of indigenous data governance and published in the CoData Data Science Journal set out these principles of collective benefit, authority to control, responsibility, and ethics. And I'll leave that slide, or the slides will be shared for the more information, but it's important to take on board those practices for engaging with data collection and studies and participation of indigenous groups with the CARE principles and other marginalized groups with analogous principles. Now, I'm going to, in the last 4 or 5 minutes, I'll go through quickly some work that CoData is doing in relation to these building blocks in this framework: open science, fair data, and care. First, we're working with UNESCO. We've had, because of the open science recommendation and the work we did there, we have a very good working relationship with the open science team in UNESCO and a joint working group called Data Policy in Times of Crisis, which has prepared a set of documentation and guidance for how to prepare policy in relation to data and access to data and reuse of data for specific situations, in this instance, emergency and crises. So that includes a fact sheet, guidance, and a checklist. Now, they were publicized and commented on in the last few months, and on the 16th of January, we held a webinar with UNESCO, which was attended by over 200 scientists, and at least twice that number had signed up to watch the recording. So please have a look at those outputs. The presentations and the recording aren't yet available, but they will be soon at the URL that QR code will take you to. And then I wanted to close with some policy recommendations which came out of the World Fair project, which was coordinated by CoData and was a European-funded but international, global indeed, project to look about how we implement the FAIR principles, and in particular to look at interdisciplinary research. Now, these are the recommendations that came out of that. And sorry, I should have said, if you want to find out more about the World Fair project and what we're doing to build onto it, into what we call World Fair Plus, there's a session on Wednesday morning as part of the ISC General Assembly, which we'd like to invite you to. Now, messages from that policy document. We need to enable research infrastructures to support 21st century science. How do we respond to the challenge that Messe has laid down? And there's a need, therefore, in the way that we deal with data to shift from what we call a bibliographic approach to data, which is you take a data set, you add it as supplementary material, or you put it in a repository and someone has to download it, and often with insufficient description of what the data is about, to a data engineering approach. And that means fine-grained, detailed description of data at the variable level so that it can be combined with other data sets and so it can be used effectively by AI for science. So the equivalent of AlphaFold in other disciplines. This is what we need. We need data aggregation, an aggregation of high-quality data for those future innovations in terms of AI. So here we make the argument for data engineering. Data engineering itself depends upon what we call metadata uplift, increasingly accurate description of the data. And not just the metadata that helps you discover the data, but the metadata that helps address the other FAIR principles. It helps you integrate the data, combine it with other data source, provide sufficient information and accuracy, information about the accuracy and the quality of the data for you to be confident and have trust that the data can be reused and combined with other data. The drivers for these have already been discussed today, so I'm going to go through them quickly. We need interdisciplinary research. We need reproducible and transparent research. We need increasingly automated and fine-grained access to sensitive data. Steve may say a little bit more about that. And we need responsible AI for science. All four of these objectives and desiderata require data engineering and metadata uplift. So that's the argument of that policy piece. And there are further recommendations there which hopefully you'll be able to have a look at. One of the things that we're very pleased about, however, is how well the European Commission, other funders and policymakers have responded to it, including the Australian Research Data Commons, which published a white paper endorsing a lot of those recommendations for the Earth Sciences, what they call the Planet Data Commons, which is working on Earth and environmental sciences, and recommended adopting the World Fair recommendations for the data policy and using the cross-domain interoperability framework, which is another output that Messe has mentioned, for the implementation of the FAIR principles. And as I said, there'll be more about the CDIF, the cross-domain interoperability framework, on Wednesday morning. And hopefully I didn't go too much over time, and I'll hand over to Richard.
Thank you. I'm Richard Hartshorn. I'm from New Zealand, University of Canterbury in particular, and I'm a chemist. And that frightens audiences who are not chemists sometimes. So quickly, are there other chemists here? I know there's one over there. Are there any other chemists here? Oh, several. Okay, that's good. You will feel comfortable, but I'm not going to talk about much chemistry, actually. If you want to know more about my chemistry, you should come and talk to me afterwards. Okay? My goal here is to provide you with examples from chemistry and to challenge you with the question of what do these things mean for me in my own discipline. Okay? So there will be analogous problems and issues in your discipline, and as I go through, I'd like you to think about what your discipline faces in a similar kind of way. Okay, so this is not a chemistry talk. It's not even, in some respects, even a data talk. It's a what are the problems and how good are we kind of talk, right? And you'll see what I mean about this as we go through. But it's chemistry light, okay? Okay. First off, what we are looking at in terms of the goals of data and the digital world we're working in is trying to get through in a digitally enabled way. So to take a situation where we're doing our science, collecting our data, and that data is carried through and recorded through in a way that we minimize the manual handling of it as much as possible, so that you can get to the point where you are collecting the data and that data goes right through and turns up in the publications and so on at the end, and is even shared then with people who read your publications later. Right? So what we're looking at in terms of chemistry is the idea that when we collect data, do spectra, characterize our compounds, that's fully characterized and all that data is linked together in ways that people can use through their lab books and so on, so that essentially they hit the publish button at the end and it all comes out. It cuts down on the huge amount of manual challenge that's associated with actually getting your piece of research published, pulling it all out. We want it all to be automatable by having fully digitally enabled workflows. So what sort of things does that mean? Well, it actually in many respects means we're dealing with fair data. Because if we can have these fully digitally enabled workflows, our data is more likely to be fair. I'm not going to go into this detail because it's already been introduced to you. But I'm going to start with the F, the findability, and talk to you a little bit about chemical nomenclature, which is actually how I ended up with IUPAC and so on. And those of you who've faced chemical nomenclature, which actually maybe many of you have done science at school, right? You'll remember that IUPAC does nomenclature, and that's what I was involved in. So the question, findability in chemistry. Here's an example. Copper acetate. It's a compound that many of you may have used because it's often used in antifungal treatment. You spray it on your fruit trees to get rid of curly leaf and similar kinds of things. So you can go and buy this in a garden shop, okay? And that's the name that you would find on the package at the garden shop. What you may be less aware of is that it's not actually just copper and acetate, it's copper 2 acetate monohydrate. You might think that means there's one water there per copper acetate, and you'd be right. But even if you did that, you would actually not be quite right, because it turns out that copper acetate, the stuff you buy, has an interesting structure drawn on the right there and would be better described as dicopper tetraacetate dihydrate. That actually is not quite enough either, because it doesn't describe the structure and the way it's put together. So there's the name that you can use to fully describe the structure. And indeed, that's only a partial description of the structure. The full name that you might want is shown there. And the question about findability is that whether your publication is the label on the package at the garden shop or in something more detailed in terms of the chemical literature, any of these names might work, and that makes it challenging to find the compound or things related to the compound. Okay? So how do you find your data? You need to think about how to label your compound in many ways. IUPAC was started by the need to develop chemical nomenclature and collate that. And it turns out that we've been spectacularly unsuccessful, because we've now actually got, 5 different names for the same thing. Okay? If we're going to be findable, we need to have other ways of doing it. And here's a more interesting example from my research. We worked with the molecule on the left and made a complex of that with nickel. The thing on the right there is just one molecule. Okay? So you might imagine that it's got a reasonably complicated name. It does. And that name is not very findable, actually, in many respects, because of the complexity and the errors that can come out as a part of that. So what do we do? One of the things that we've got is the International Chemical Identifier. This is a concept, a thing that might actually be useful to you in other disciplines. If any of your disciplines actually needs to use a chemical, in this case an amino acid, then you can use the International Chemical Identifier as a string that can be entered with your paper that tells everybody that this compound is part of your paper. You don't even have to be a chemist to know that, you just need to have the string there and put it there. So what we've got then is an identifier which is more useful than the formal chemical nomenclature that you got tortured with when you were at school. Okay? So we've got this, we've got two forms of it. So the full International Chemical Identifier is on the top there. The second one is a standard length one called the INCHI key, which is better for searching. Now the problem we've got is that this sort of thing can, well, you have to know where to use it and you can get more information about it. Okay, this though is more helpful in terms of general publications and keeping track of things. And indeed, in terms of our digitally enabled workflow, if we label all of our spectra and all of our things related to this molecule with that identifier, you can use the identifier to tie everything together. That's where its value is. Okay? Challenges though. You will have been hearing about ChatGPT. If you've got a non-chemist and wants the identifier and doesn't know how to get one and make one, you might ask ChatGPT. If you do, you have an interesting problem because for different compounds, you get answers that may or may not be correct. Depending on your point of view, you might find it remarkable that ChatGPT actually produced the correct INCHI and INCHI key for ethanol. For acetamide, a closely related molecule, it got the right INCHI but the wrong INCHI key. And for a more complicated molecule, it didn't get either of them right. What's really important here, though, is that in all cases, the generated hallucinatory INCHI or INCHI key has the form of an INCHI. If you look at it, it looks sort of the same. If I didn't highlight it, you wouldn't know it was different, right? It's got the same number of letters, it's the standard length for the INCHI key. It looks like an INCHI, even if it isn't the right INCHI. And that is a problem because it means that if you see an INCHI, you don't know if it is a real one or not. And what that leads to is one of the things that we need to take home from this, and that is that whatever you're doing, you're going to need to have significant validation protocols to be able to establish whether the thing you're looking at is correct or not. Okay? In this case, INCHIs, but it could be other things as well. So you need to look at the issue of validation in significant ways. Chemists, what can we do? We collected a lot of data, but the question we have to answer is what do we do with it? And in order to know what we can do with it, we have to be able to answer some of these questions. What does it look like? How is it stored? In what format? A big one is units. What units are with it? Because if you don't have the units, then the data's useless. And in fact, CODATA has a whole task group that's looking at the digital representation of units of measure as part of how you can make your data sets usable and machine actionable in ways that are really useful. And then you need to know also things about when and how it was collected, under conditions it was collected. The temperature matters. Room temperature in the tropics is quite different from room temperature in winter in New Zealand, and your chemical reaction will go quite differently under those conditions. So this is a key point that we have to bear in mind, is that metadata is just as important as the data itself. And probably what I should add to that is that if you want your data to be in, or you need your data to be in a standard format, your metadata also needs to be in a standard format because the metadata is also data. And that's a critical issue. So how's chemistry doing? I don't want to go into this as an analysis of what different publishers are doing. The answer basically visually there is green, dark green is good and red is bad. And what it means is that in terms of chemistry and the publication, or the publisher's world, chemistry is quite good in terms of details about the author, ORCIDs and things like that. Okay with some things, in particular X-ray crystallographic data, where there's quite a lot of work done, and so that's the dark green on the at about 8 o'clock on the clock there. But all the detail around spectroscopic characterization is all the red stuff at 10, 11, and 12 o'clock there. Chemistry has got a lot of work to do. Here's an example. This is the kind of data that I have shown recently in a paper. This is what chemists regard as showing data, and it's not. This is a PDF picture. There is no data in this, okay? For those of you who know about chemistry, that's an NMR spectrum, nuclear magnetic resonance spectrum. The actual data from that technique looks like that, okay? It needs to be significantly processed in order to get something that is interpretable by chemists, all right? What it means is if you want to reuse the data or look at the data, you need to have access to the free induction decay, that complicated piece, or the complicated set of data. And that is not shared normally, all right? That's a X-ray crystal structure. That's one of the better parts of our discipline in the sense that we do store some of this information. But that's not data either. That's the output from it. The data are intensities of diffraction spots. And only rarely, relatively speaking, is that data stored. So, take-home lesson here, we need to publish actual data, not pictures of it. How many of you show graphs in your publications, right? Graphs are not data either. You actually need to be storing it and have the graph constructed as part of the publication, so it's automated in some way. So we need to actually have things a lot more available and be thinking about things like that. Garbage in, garbage out was mentioned in a question earlier. That's certainly true here. We train AI on data so that it can be a predictive tool of some sort. We need to ask how representative that data actually is. Now, for chemists, there's issues around reproducibility, one of the R's that we talked about, okay? But in particular, there's questions about the culture of chemistry. Chemists have a very strong tendency to publish their best result rather than their typical result. So chemical yields, how good you were at doing the chemical reaction. It's very common for people to publish their best outcome and not the one that your average chemist would produce when they went in to do it. That's a real problem. And the biggest issue we've got is we never, ever pretty much publish our failed experiments. Because if you want to use AI to start doing things about predicting the outcome of chemistry, the failed experiments are actually at least as important, possibly more important, than the ones that actually worked. So we need to change our attitude towards publication of failed experiments as well, and all the data that goes with them. So there we are, a key outcome. We need to say something about outcomes, and we need to say some more about what did not work as well. Finally, almost finally, there is another issue that comes about in chemistry. I've got a more detailed example about this. But how many of you have had embarrassments when your word processing software has made automated changes to the spelling of things? It happens a lot in more scientific areas than just the words that are on the page. It happens in more detailed situations when you're using machine processing to deal with data. Depending on the whims of the programmer, there may be things that happen automatically as part of the software that is processing your data, and you need to be very aware of that as well. And that has profound consequences for education in the sense of the degree to which we require students to understand what's going on inside the black box. Okay? We might not have to show them everything, but we need to stop and think about what's in the black box. And so the last bit there is to acknowledge the people who contributed some of the chemistry data that I did show. So two of my PhD students up the top there. In terms of the data-related work that's happening in IUPAC, Leah McEwen is doing a fantastic job on the Committee on Publications and Chemical Data. Anyway, one of the committees. Jonathan Goodman does a fantastic job in some of the things related to the INCHI, and the whole INCHI Trust has been doing work on the International Chemical Identifier. And finally, there are thousands of chemists who work in IUPAC, and they all contribute voluntarily to much of the work that IUPAC does as part of the chemistry, and I want to thank them. And you should thank all of your people in your unions as well, whenever you possibly can, because then they'll keep doing things for you. So that's me done and dusted.
Thank you, Richard. Okay, can I just check in with Simon? It's 4:03. Timing-wise, how do you...
15 minutes each, yeah.
Brilliant.
We're only 3 minutes over. So.
Yep, excellent. Okay, I have a tendency to talk for a long time, so that's why you're best off getting the short version from me. I'm going to presume... Okay, so the social sciences. By way of introduction, I run a social science data archive is my day job, along with doing some, lots of work with CoData and others. A lot of my day-to-day work is really about thinking about how do we support data access, reproducibility, and the like in the social science. So how do you get data to where it needs to be to do the sort of things you need to do as researchers? As a researcher, my background is in an area called labour relations, and more recently around just essentially public opinion and public attitude. So the sorts of questions around sensitive topics, sensitive issues. How do you ask questions about political preferences and so forth is the sort of work that I have tended to do. So in the social sciences, and I'm going to sort of talk generally about 2 of the 4 areas in FAIR. This is really about access and access to data is the first section. Later on, I'm going to talk more about interoperability. What happens when we try and put things together? That's really kind of the emphases that are here. There is a lot of social science data out there. We had discussions about minority groups and so forth. Actually, it works in both ways. Sometimes what happens is minority groups are overstudied at the same time as well. And ethically speaking, you get the reverse problem, which is the data that's produced that should be shared and isn't. So there are variations on a theme there. There is definitely missing data, but sometimes there's too much data that isn't in the right place. So, all areas to be considered. So, I'll talk access, I'll talk interoperability along there. I'll start with access because, getting access to the data that we need presumes that data exists itself. That's a findability problem. Have we, saved it? Have we got it available for reuse? Social sciences have done that very well. In the 1960s, we figured out essentially this was a good thing to do because we were interested in comparative problems. Why do different institutions, why do different structures emerge in different domains? And so you had to be able to share data between locations, between countries and so forth to be able to do that. And that was the origins actually of the archives as well. The hard part for us is the sensitivity question, is we ask things about people. People want access to information about others, but generally speaking, don't want information about themselves to be shared. Now, the others in themselves, of course, are the same group, so we have an ongoing challenge of bringing those sorts of trade-offs together. And now I touch upon that in that idea of protection versus utility. You have to be able to do both. There is no right answer to this. So we do the best we can. Okay. And that comes, ties into things like governance and data management, both preservation and protection of data and metadata. And that's why we talked a lot about accessible rather than open. For a social scientist, often open is not really an optimal solution. You have to be able to recognise the importance of open science, trade it off against the importance of maintaining the rights of the individuals who are being studied. And that's that is a trade-off that we have to manage essentially. No one will tell you the right answer. You have to be thinking about what are the options there. Okay. So a lot of this starts with governance, and Simon's touched a bit on the Indigenous data governance as a good example of that. More generally, these themes do cross over sort of data access considerations generally. When I talk about this, I sort of look at the different frameworks for which it's happened. I've moved from Australia to the UK. Actually, the themes do come across fairly consistently. I've worked quite a bit in Indigenous data governance in Australia as well. There are particular requirements for particular groups, but there are definitely some themes we can have there. Broadly speaking, around legal and ethical considerations, in the particular case in Australia, we have sort of frameworks emerging, which started in the UK, went to New Zealand, came to Australia, and sort of evolved there in terms of a means of doing that. We talk a bit about data management and FAIR principles as well. Let's just start with legal and ethical responsibilities here, though. If you're a researcher or you're someone who's responsible for access to data in Australia, these are the various types of legislative frameworks that you have to be dealing with, or ethical frameworks. So we have a generic Privacy Act in Australia, and that covers responsibility for access to data held by, broadly speaking, public agencies and organisations over a certain size. So they apply to universities in Australia, which would, that are state funded, often applies to those receiving federal funds as well as state-owned agencies as well. So you have generic principles, you have often frameworks or legislative arrangements for access itself, and this is increasingly becoming the case in a number of countries as well. You could put the General Data Protection Regulation of the EU into that sort of framework as well, into this space. For federal agencies or state agencies, you often have specific legislation which control access, particular types of data as well. It might be you've got levels of regulation that exist. In Australia, we had states and territories. We even have we might have international legislation. What are the UN conventions actually putting on you? And then you have not legislative arrangements, but regulatory systems. So it might be codes of ethics. It might be institutional review boards and so forth that are relevant there. And as I say, in the Australian case, every academic researcher is subject to if you're doing human subjects research, the National Health and Medical Research Council oversees that. And all the institutional review boards are subject to that legislative framework. So we have these layers of governance that kind of come along with that. The other side, so accessibility partly is about governing the access models that you have there. Do you have the right information once you have the data that you want to use? And others have talked about documentation and metadata as well. Data without documentation, particularly data in the social sciences, is essentially useless. I've got data back to the actually the 1830s and going further along there. But if you have that information, you can continue to use it over long periods of time. Once the documentation, once the metadata goes, the data itself is essentially just a set of numbers or just a set of words. A table is a table, but if I don't know what the rows and columns means, there's not much I can do with it. It can be on multiple levels depending on user requirements. And this is kind of what Richard was touching on as well. We do see these themes coming across domains. So it might be a collection of content. Here's a project idea. Here is a database that I have. Here is a service, that I run. But I might need to be more specific. I might need to know about a particular file or a particular table. What's that Excel spreadsheet? What's that, R package? Sorry, the format, file trying to do, etc. Or it might even need to be down to the level of the variable or the item, or even down to what is that, literally where did that particular piece of information from that cell come from? Now, the key message here is for machines to be able to do what they need to do, you need to be going very down into the depths here. Humans can interpret things very, very quickly and easily. It turns out for machine interoperability, that fine-grained detail, which essentially metadata is the bit that really is needed there. It needs to be able to operate on something. Can't figure it out until we see the algorithms, sufficiently complex to be able to do that interpretation. Okay, and that's where the metadata and standardised metadata becomes particularly important. Social sciences has done well in standardising our metadata and systems. This is often a result of interaction between government and academia. We study humans, governments managing human interactions and government responsibilities. So a number of standards and services have emerged from that, which we can take advantage of. There are also interoperability standards that exist for a lot of collections coming from major international organisations. Some of them often had their origins in essentially the development of the collections of economic statistics over the last 50 years post-World War II. And so they are subjects of federal regulation as well. Okay, that enables the data access and sharing. We have to think, when we're thinking, a lot of our governance models though focus on the trade-off between protection and sharing. What is the risk to individuals of making that data available versus what is the utility of having that data accessible for research and analytical purposes? And this is a trade-off that most governance committees are having to deal with in that process. So your models for governance essentially need to be able to deal with both of those things. Do we have appropriate protections but appropriate review processes to balance those risks? What do we need in order to do it? Well, essentially, To running those systems, we need a combination of technical, administrative and government services. And increasingly, as I say, how are we going to sort of support both human and machine access to data? Those technical services are becoming increasingly complex and require increasing levels of information. They also add, though, layers of administration, and many economies, essentially, those administrative services from governing access to data have actually grown, rather than reduced. It's becoming harder rather than easier. The more we can do, the more we want to do, the more we want to do, the more potential risk to those who are subjects to the data itself. So it doesn't always scale in the ways we expected. Righto. So that's kind of the themes around data access, the sorts of generic challenges that we're dealing in terms of managing access to human data. What about when we want to put it with something else? Data interoperability. How are we going? All right. Turns out interoperability has its challenges as well, and this is where a lot of my focus and my work in working with Worldfare and others has really focused in recent times. Sorts of information we have about human social relations. This is a standard question. This is a single question which says, what's your current employment status? We actually do recognise these. Many of you will have done these sorts of questionnaires at different points in time. What's your status? This is from an international collaborative survey. So we have in research terms, we have a variable. We often have a question that was the basis for the variable. You asked a question, you got an answer, you put an answer in a cell. We have a set of possible responses. Any and all of those things, unfortunately, become concepts. So what is what do we mean by your current employment status? An apprentice or a trainee? How does that change when you change languages? So lots of different dynamics. Understandings, conceptual understandings, become a challenge for the social sciences. So concepts everywhere. But how do we connect the dots is one of the interoperability challenges. We can do codes, this is the response I gave, but the interpretation becomes the challenge often in the social sciences. So we need to be able to connect humans to machines and machines to each other, and increasingly the machines to other machines is the growth that we need there. Humans, we make errors in the process. Machines can identify differences, but they can't interpret the differences. How do you reconcile that conceptual understanding of the human with the interpretability difference of where the difference exists? So just to take an example, first work we did, they were very simple machine learning algorithms. The machine couldn't distinguish, that couldn't identify these two things as essentially talking about the same things, and it was entirely to do with grammar and sentence structure. This is the answer that people gave. There was a couple of things stuck in the middle there. I say credit, those are solvable problems, but they are problems that we continue to have issue. Secondly, we don't always have content available in machine accessible or machine processable forms. Richard's comment about pictures in tables is a big one in the social science as well. Stop putting tables, put in the code that generates the tables is really what we're going there. Or it might be in HTML. HTML is not sufficiently structured to be able to do something with things. So the work we've been doing, and this is part of the Worldfare project, is trying to figure out standardised processes for doing the sorts of harmonisation. This is just harmonisation, one questionnaire in the social sciences. The more work we do on sort of understanding the process of how we do that sort of interoperability, that matching, that engagement, the more we can do to standardise, get humans doing what they do well, get machines doing what they do well, but we need that sort of iteration and interaction between the systems in order to do that. So this was an outcome of the Worldfare project work package that we did. We kind of highlighted green, well actually it comes up as light blue here, meant it worked well. Yellow meant, well, we had some success, but it needs more work to be done. We didn't have any failures, but we had some things we couldn't do because there wasn't sufficient information there. It's even, oh damn it, I'll go backwards, sorry. It's even possible to start automating some of this once you know what those workflows are. The specifics don't matter here, but that's actually the same question. What happens when we start be able to use some of this? You can then, and understand those workflows, we can generate automated processes. But we need some basic infrastructure in place in order to be able to do that. And it's not dissimilar. The content is different, but the requirements for the sorts of things that systems need to do actually turn out to be quite similar to the sorts of things Richard was talking about. Standardised access is one that's particular for the social sciences, but a repository of where key concepts are, how do you reuse that information effectively in the sorts of systems that you're using, and standardised practices, code systems, again, leveraging the sorts of things like identified objects, identified concepts and ideas. We can develop sort of common tools to do those sorts of things. And that's where we come to it in the social science.
Thank you. And I'll very briefly introduce what I'm going to talk about today. So I'm Shelly Gandhi, originally from India, currently working in Austria, Linz. And I have been part of CoData since I was a PhD student. So I have learned my data skills pretty much with CoData's data school. And I'm going to talk a little bit about how we have been doing everything and how things have really moved forward. No. The big green one. Long green one, okay. Yeah. Yes. Okay, so this is a pyramid which I tried to put together to talk about the data skills. And the interesting part is, like, of course, every researcher needs to learn data skills from scratch, but do we really have time for all of it? And no. So the base of the pyramid talks about project management and time management, which is extremely, extremely important to really talk about relevant skills you need for your domain to do your data publishing, understanding how these data sets could be reused by someone else. Because if I'm doing a research which is very off the beat, I'm collecting data from, for my PhD, I collected data for chemical drug stores in India. And that data was very sensitive, not publishable. But then what was the result of my PhD was I gave them back a structured file saying that, okay, look, you don't want to publish it right now, but use this data in this format, which would be very useful. The second part is always collaboration and interpersonal skills, which is important and which could lead to, you know, being a better researcher. There's no harm in not knowing anything, and there's no harm in asking for help if you need. And same goes with communication skills. Here, there are two kinds of very important communication skills when it comes to research. One is scientific, where you need to publish, you need to share your information in a very, very scientific way, which is understood by your domain experts. But the second one is more effective way of communication, where you share your outputs with more larger audience who do not understand what chemistry is or physics is, but try to talk about something which is more interdisciplinary. Try to talk about things where the research goes really ahead, and that's the need of the time. And then more important from research perspective, which I put on top of the tip, and it's always that you need so much to be a researcher, do your PhD, postdoc, or anything else, and that's critical and analytical thinking skills, which is extremely important. There is so much research going across the globe, and we see that there is very, very little interconnection. I think there are hundreds of use cases being done, and why don't we share those research? Or why can't we find those researchers? And that's where critical thinking and then technical and methodological skills is something we all learn as research data or research methods as a course in your curriculum, and that's important. But to reach there, I think everything else in the pyramid equally contributes. And that's where we're going to talk about why data skills really matter. And we know that there's a lot of talk going about AI. We are talking about how things are really going in different domains, how AI is being embedded in various aspects, not especially like to do your work, but we take AI in the loop to help us do our work more efficiently. And at this time, if we say data science is one of the skills which every domain needs. And it's not only programmers, but data science skills are something what you can actually reuse to reproduce a lot of laborious work, what you're doing in your research. And one example I can say
is from my current research group. One of the PhD student has been working a lot on annotating semantics, especially like the sentiments from social media data. Like millions of posts are there, and he's using active learning method using ChatGPT models to annotate these millions of posts to find whether they are relevant or also identify the sentiments. So sometimes using technology in the favor of producing effective outputs is what we would encourage. And by having these data skills, one of the main outcome and very, very useful one is to support interdisciplinary research and open science. Okay, I have purposefully put this image from ChatGPT to really say that it could do a lot for us. And foundation of research data skills is that you need to know proficiency in data analysis, identify and experimental design, especially when we talk about research. You need to know what is the objective research questions, how you do it, why you do it. Coding languages like R, MATLAB, and there are many new languages which are coming up. There are many new platforms which are being used to compile languages, multiple languages in one platform, and that's also something which you could leverage as a skill. A lot needs to be emphasized on open science practice and reproducibility of the data, because it's not being taught as a curriculum anywhere, right? You do not know DOIs or ORCID IDs when you start with your master's or PhD program. So that's something which is very important to be known in the research community for having more accessible data sets. If researchers are not aware of how to correctly publish their data in open platforms with required licenses and credentials, is again a skill which could be very nicely acquired. And then a lot about ethics have been spoken by previous speakers, so I wouldn't touch base upon that right now. And last is presenting your research work. So I don't know, but I'm going to very quickly ask in the audience, how many of you think that this image is good enough to represent research data skills? And you can just raise your hand. No one, right? So yes, ChatGPT can create beautiful images, but you need to be very careful in using them and saying like, yeah, it's good or it's not. So that's where the active learning loop of rectifying and correcting the images comes in. The next one is making sense of complex data, and this is also a very big topic in itself. Data sets come from various domains, various platforms in different formats, in different capabilities. Also, these data sets come with a lot of differences in terms of geographical aspects. Say, I have data for a city, I have data for a building, and I have data for whole country. So which level and units of data sets it is. So first and the most important skill, what you need for this is identifying what experiment you're going to do, what kind of data you need, which disciplines it could touch upon, how do you interoperate these data sets and make them talk to each other, and how would this whole thing make sense? And as Marcia has already emphasized in her presentation, talking about how adding one more domain in a research could really enhance its impact on the society. So critical evaluation of all these results is also one thing which leads to more impactful and good results, which are useful for societal good. Teamwork is also a very big thing, and that's what we learn extensively in the data schools, is how do you bring these disciplines together? How do you really talk to a chemist or a physicist or say someone who's from social science background and say, oh, look, we have this problem and let's solve it together. It's really, really difficult, and that's where fair data sharing practices could help. At least that questionnaire could help in identifying what is missing in my data sharing strategy and how do I make it fair. And what we would say is building effective research teams is important. What Mercy again emphasized, having a team which has people from different domains, and they talk to each other to make sure that what they are trying to achieve as a common goal is achieved towards the end with clear understanding. I wouldn't say that everyone needs to be an expert in all domains, but the minimum understanding of each other's domain and understanding of how you achieve the goal, what you want to together is important, and that's where the entire fair data principles in data sharing comes into play. And the most important slide for people who are here representing the young research academy is we have, as part of CoData and Research Data Schools, we have been doing a lot of data schools which talk about data stewardship and fair principles across the globe. So it started, I think, in 2015 with Beijing being the first one, and then schools which were more advanced in nature at Trieste in Italy. I have been part of these schools, and I would highly recommend people to at least see if it could benefit people, or also host one in your country, because it does not talk about the basic things what we really learn in our curriculum, but it talks a lot about like how do you implement FAIR, and implementation using real practical or lab sessions is what is important, because there's a lot of theory and a lot of data generated by ChatGPT if you ask about FAIR principles, but doing it together with instructors make it really worthwhile. And creating and managing metadata is also a skill which is taught in these schools. And a big part of ethics is covered. So very briefly, I'll talk about the topics, what were covered, and what we have achieved after that is we also had very good advanced workshops of 1 week, which spoke and deep dived into these topics. Like we had very interesting urban data science, IoT, and big data workshops. Now, the best part about this whole thing is like, right, we learned the basics. Most of the alumni came back as instructors, and they also curated very good content for the advanced schools. And this is where we see the skills being implemented in a domain and being translated back to the community. So this is where we as CoData, Early Career, and Alumni Network contribute a lot, bringing the knowledge gained back to the community and also spreading it with young researchers around and across the globe. So yes, with that, I end. Thank you very much.
Thank you very much, Shaili. Thanks to all the speakers for this session, or this part. Now we've got half an hour left. We originally had this plan, we might break people up into groups on the basis of subjects and have discussions in the groups. Do we want to still do that, or just have the open discussion? Messe, Richard, Steve, Shaili. Yeah, I mean, because I think people might want to feedback on that, because that's been 4 presentations in a row. Okay. So, we'll give you, yes, are there any questions for any, and remember there was four presentations there, one on policy, one on chemistry, and the chemical reaction, or the chemist's reaction, I should say. Please, your question.
Hello, everyone. I'm Fadlina from the Academy of Sciences, Malaysia. I'm the chairperson of the Young Scientists Network. I'm also a professor in AI and data science. And coincidentally, I'm also the chief digital officer of my university. Hearing today gives me a lot of things to think about. In Malaysia, we already have a policy about data sharing. We have Malaysia Open Science platform. And on top of this, we actually have several other platforms available. However, based on some analysis that I have done personally previously, I saw that the pickup of scientists in data sharing is still low. I would say because the regulations is not there. So my question would be, because thinking about for Young Scientist Network to go forward, maybe we can come up with this resolution through this engagement with CoData, or maybe coalition with other early career researcher groups to do this together through our networks. Just thinking about what is the best way to unlock these scientists to relearn, because to me, when I approach them, they say they already know data science, they already did. But the way that they are sharing previously is still the typical publication-based dissemination. So maybe if there is something that we can refer to get to practice FAIR properly, because the platform is already there. Only a small group of people have been contributing, but this is not in a large scale. We have transdisciplinary research and so on, but not many are aware about how to do FAIR Plus properly. So what is the tips, if you can share, to really inspire people on this why and so on?
Yeah.
Thank you.
Thank you. I think that was a very rich and complex question, and there's lots of areas that we'd like to answer. I'd like to make a sort of preliminary response and then see if any of my colleagues would like to come in. Surely engaging with early career researchers is important, and training in those new skills and new approaches to science and open science is really important. There's a really important policy dimension as well, particularly in terms of incentives and requirements and what we want out of science. There is a scientific culture which does need to be changed.
So you're suggesting top-down?
Well, I think there has to be a bottom-up, train the young scientists. There has to be a top-down policy. I think there also has to be enable. And so we have worked with the Academy in Malaysia before, and worked with the Academy to promote the idea of open science, and worked on the Malaysian Open Science Platform. I think this sort of initiative is really important because it enables. So if you like, you can say top-down policy, you can say bottom-up training, and you can say middle-out enabling with infrastructure. You need at least each of those three. Yeah. And I think Messe would like to come in, and perhaps Richard as well.
No, thank you, and I agree with those. I just would, I mean, maybe it's part of the enabling, but I think the incentives at the, for example, in the academic organization level, at the university level, to say, well, if you publish in the sense of you deposit your data code and so into the repository, this open repository, right? This is also something that we use either for promotion, for credit, for recognition as a better scientist, right? If you do that. So I think building those incentives is also important.
Thank you. I'm looking at that way as well, because to have sustenance, we already have the platform ready. So now worrying that the idea might die and people are not really continuing.
Right. I mean, I can tell you some examples of what some universities have done to make it like almost, well, for example, a required course to do to see how you're going to deposit the data, why is it important, what are you going to do at the end of your your studies and your work, and that's a required course for everybody, and so and other things like that. I mean, sometimes it's more enforcing or regulating so that there is this required training, but other times that works even better if there are the incentives so that you want to do that for advancing your career.
So in terms of the chemistry sort of side of things, which may be generalizable, the green and red graphic that I showed, the dark green, which is the good bit, was inflicted by the publishers, or was induced by the publishers, because the detail regarding the authors and so on was helping them do their business, and because the detail regarding X-ray crystallography was again helping them with their business with the refereeing. The challenges with much of the rest of it are actually the enable word, where the detail around the characterization and so forth of the compounds, the mechanisms are not currently there in terms of having the right repositories and the right ways to link them and things like that, as well as the tools like the chemical identifier that allow you to tie it all together in a way that it can actually be used. So the issues there are around the enabling of it, but also critically, I think, the attitude of the chemists themselves is to hold their data to themselves because they're thinking that they don't want to get scooped on the next bit, they want to get the next thing and stuff. So
the embargo part is also could be important for their career. No, that as we think of open science, I do think that an embargo on your data, I mean, especially now there will be more models that the model itself could bring a lot of output, that there is an embargo on opening that data until you have published. I mean, in astronomy, that is often done, that the data is not in the public repository until you get the first one.
Indeed, yeah. So embargoes can help, but I think a big push is going to be around the attitude of scientists, and that's where I think the young scientists can really help drive things. You know, when we think about improvements in academia, so much of that is driven by what the early career people and the students are doing. Because too many of us old grey professors, we do things the way we were taught and don't get very innovative about stuff. We learn stuff from our students. And we need to do more of that, and there's a real opportunity for that.
Yes, and very quickly, like there is a whole repository of the training materials, what is being taught in these summer schools online on GitHub. I can share that with you. So one way is, of course, you can call in experts and do a very concise bootcamp thing for the students, and also talk about the incentives, what they get by publishing their outputs. It's not just for the university or for a bigger goal, it is more useful for their career path. So as soon as they understand that, probably it's going to be more easy for you to encourage people share their data in a better way. And secondly, at times it is necessary in certain cultures and regions to have it coming from top to down, right? So both the approaches would be necessary if you want everyone to use it. Thank you.
Steve, did you have a comment? Or
One quick one is say, I've been the person who's been trying to get data out of people for 20 years. So all of these things, it is incentives. It is publishers are actually the big driver there. Standards matters here. Change happens from younger researchers. The one other group that I would pick up there, though, is actually people who are ending their careers. Because what happens is, why do people hold on to things? And this is an incentives, conversation. Why do people hold on to things? Is because there's more value in holding on to it than there is to giving it away. But what happens? The experience is end of careers. Well, now you're more concerned about your legacy than you are necessarily about, you've done all the work you're going to do, and it's actually, someone else can actually have, get benefit from the data that's there. And we do actually have, the experience that I've had is working with researchers who are later in their careers, essentially don't need to get now, another publication is not going to add that much more there. What they've got is something else, making sure that the data they've produced and collected, which is in itself as value, is there for another generation. So there's a change in mindset, but it is essentially, it's a human choice there. So sometimes the top-down government or the publishers drive it. Sometimes it is bottom-up. The young researchers often working with actually, their supervisors and so forth. But as I say, there is, one other group there that I'd just pick up on.
Thanks, Steve. Any more questions or responses from? We really want to hear from you about reaction to the. Yeah.
Hello. Just a comment. I am Graciela Diaz de Delgado, I am Vice President of the International Union of Crystallography. And I was a little bit puzzled about what you mentioned regarding the deposition of crystallographic data. I think in this case, or in our case, the need to deposit at least a kind of complete basic amount of data about a structure. It came, of course, from the publisher, but in our case, the union, the International Union of Crystallography, is a publisher of 10 journals at this moment. So, in a way, all the validation procedures and the need to deposit the data came mostly, I would say, because a lot of the chemistry journals were publishing structures where they were sometimes wrong, and because they considered that it was enough with the importance from the chemistry point of view of that material, the novelty of the synthesis reaction, things like that. So the International Union, I just wanted to make sure that it's recognized because the union requires, and little by little made all of the publishers, all of the publishers that present and publish crystallographic data require the ZIF file, which can be downloaded. It's available to all readers of a particular publication without a need to have the subscription to the journal. Now we have most of our journals are open access or hybrid access, and we have also started to collect or at least store raw data so that other researchers can use it and also study that. So I just wanted to point out that in our case, as a publishing union, we have done some work regarding having data that is accessible and that can be validated and even studied by other researchers, and maybe in many cases improved also.
Yeah, I apologize. I did not do true justice. I should say the International Union of Crystallography, they are the stars in the chemistry space. And they look like the diffraction pattern with the spots of light that are fantastic. The point there is both around the fact that they produced a standard that the CIF standard is a fundamentally useful standard that does the real basics. Arguably more important, though, is the Czech CIF validation that goes with that, and the enhancement of that that's gone on with time in order to deal with things like the publishing mills and whatever that came out of certain countries. So the crystallography standard is something that we aspire to across the other parts of the discipline, I think, in that respect. The driver, though, was the wide acceptance in the publishing industry of the utility of the CIF in terms of helping with the reviewing and so on. But right. The fantastic work that was done by the crystallographers, true admiration. And if we could make the other parts of the discipline work so well, we'd be much better off.
Okay, thank you.
Okay, I'd like to add to that, because I think so. We do recognise and work a lot with colleagues in IUCR, and the development of CIF and Czech CIF are obviously really important. But you did say, you're encouraging the development of crystallography databases for the raw data, and we are aware of some of them. But it's also the case, if I understand properly, that is a newer development. And I know there's, I regret I forget his name, who emeritus professor, University of Manchester, that we've worked a lot with, John Helliwell. I know that he published an article in the IUCR journals saying why we need raw data. And I think Richard's point was, yes, CIF is really important. Yes, Czech CIF is really important, but we need the raw data as well. And IUCR is way ahead of a lot of communities in that, but the raw data is really important. So, please.
Yeah, thank you very much for the opportunity. Well, I came in late. Mine is just a general, question. I realized that the dynamics in data curation, collection is very different. And there's a huge gap between countries. I'm just wondering, is it possible to organize specific capacity building for different, different countries, so that, at least we can try to bridge, maybe not completely the gap, but at least, to bring our people up to, to understand. For example, we have so many postdocs and PhDs. We've collected data over the years. They're sitting there. There's a huge information out there. How do we train so that we'll be able to, capture? For example, you said the insights in some of these. How do we do that? So, mine is a possibility of organizing capacity building workshops at continental level. Sorry, I'm from the African Academy of Sciences, the executive director, and we're looking at, this area, and especially to link it to open science, which I've driven over the years, but there's a huge gap. So I'm just wondering if such a capacity thing can be replicated, particularly for me in Africa. Thank you.
Thanks. If my colleagues don't mind, I'd like to take that. And obviously, we've worked a lot in the past.
Exactly.
So there are at least three dimensions as how do you get the generic data and open science skills into the disciplines and then into the universities. And then how do you do it at a national or even a regional level? If you add all that up, that's a huge challenge. But there are small steps that we can take. The initiative that we do with the Research Data Alliance is, I think, has been incredibly useful for the hundreds of young scientists that have followed that course, and Shiley attests to that. But our real objective in that, yes, it's to benefit those participants, but is to try and move the agendas in universities and get universities thinking about we need to incorporate this sort of training in our undergraduate and postgraduate fundamental science skills. And when that happens, then we can say, okay, we don't need those residential or short courses anymore. In the meantime, yes, we do try with the level of capacity that we have to do those courses in various institutes. And so we've worked with universities in Addis, in Pretoria, in Nairobi, elsewhere. The other dimension is the subject-specific skills. Now, a lot of the data skills, as Shiley said, are generic, but the way the student wants to implement them is often is to do with their research, their postdoctoral research, their doctorate, etc. And so we need to think about how we translate it to the needs and to the language of particular disciplines and how we implement it there. And it requires that enabling infrastructure as well. In September this year, we collaborating with UNESCO IOC Africa on training in fair and open science for ocean sciences. And guess what? The director of UNESCO of that program in UNESCO IOC Africa is an alumnus of the data schools also. So these are little baby steps. But I think through those sort of mechanisms, we've collaborated in the past with the Malaysian Open Science Platform. We can make progress. We can't fix it all overnight, but we're very, very keen to work with ISC members, to work with at a national level, to work with the ISC regional offices, and to work with the international scientific unions to explore how we can address those various levels: the subject, the national, and the regional. And really, I think that's all I can say, Peggy. I mean, it's it's something that we're working on, and we need collaborations to make it more effective.
I want just to ask if we can have access to the presentations of today.
Yes, I think that's a simple answer. Yes, they will all be open in the interest of open science, and they will be shared. I don't know the precise mechanism, but I'm sure ISC and the Global Knowledge Dialogue will be making sure they're available.
Thank you. And I have a comment. I think that to share data, to have many skills in around the world, and I am thinking for Africa, without data centers, without a connection, correct connection, we can do nothing. I try to have some data from CERN to Morocco, and you cannot download data because the volume is very huge. So with the data center, I think in the future we will have a data center funded by a private company of phosphate, and I hope that we will solve this problem. It is not skills. Young students, very excellent students, are available in Morocco. Researcher in high energy physics also, but infrastructure is missing. And I hope that we will have data centers and an organization like Tier 0, Tier 1, Tier 2, Tier 3 around. In Africa, we have nothing. So it is a recommendation is infrastructure.
Yeah, yeah. I would certainly endorse that, and not just raw or vanilla infrastructure. You know, it's not just enough to have. It's not enough to have the buckets and the pipes and the compute. Though the program to develop NRENs, National Research and Education Networks in Africa, has been very successful, or I think relatively successful. What we need above those, above that basic infrastructure, are the sort of institutes that Steve runs in the UK, the specialized data services for particular subjects and for interdisciplinary research, who look after the data and who curate the data, who steward the data, who make sure that the data is of high quality and well described, and therefore reusable, to make sure it's fair. Steve, do you want to comment?
Yeah, I mean, I'll just make a quick point on that. As I said, there isn't a strong network of academic research infrastructures in the social sciences in Africa. As I say, I know of South Africa and one or two other places, but that's kind of it. What there is, though, and this might be something just to explore, is the World Bank has invested heavily in the official statistics offices, particularly in Africa, and in parts of Southeast Asia and like all, and somewhat in Africa. And there's been a program of both capacity build. It's been a while since I've seen the capacity building part of this, but certainly the infrastructure side, they built essentially out a microdata sharing network for the social sciences, and it's in about 90 different countries, and it's behind the scenes for all the UNESCO, all the WHO, all that. So in the social and health sciences, it exists, and it's not obvious that it is there. But that was a fairly heavy investment by the World Bank to get, as you say, I think it is both things. It's skills and infrastructure. You kind of have to be working with both, but they invested in both, and I think that's sort of the point that's there, is you have to be able to bring both on at the same time. It's been a while since I've looked at that, but it occurs to me that there has been a coordinated effort that's there that might be worth visiting.
I'll mention two more examples in Africa, or maybe three. At the same time as we were working with the Malaysian Academy for the, and when I say we, ISC and CODATA, to that idea of the Malaysian Open Science Platform, we were also working with NRF in South Africa and other African countries for an initiative called the African Open Science Platform. Now that's ongoing as an initiative funded by NRF to try and develop a pan-African network of collaboration and to provide that infrastructural support. The director is Tiama Mochegwa, and I can certainly He may well be known to you, but I think they're doing some very good work. But yes, they need collaboration, and then they need reinforcement, and they need resourcing. The second is that for a number of years, CoData has been working with the African Population Health Research Center based in Nairobi. Now they, over many years, with funding from various sources, but in particular the Wellcome Trust, have developed a considerable expertise and infrastructure for data science in population and social science. Now that has almost been a sort of a form of academic entrepreneurialism within the funding system, but I think they are a very good example of how that can be done. I suppose the third would be H3Bionet, which has been a Pan-African initiative in genomics, which has also been very successful in securing funding for a Pan-African initiative, and again, the infrastructure and data science skills that are necessary. So it is possible. There are good examples in certain fields, but it's limited. Christopher, did you have we're beginning to run out of time. Do we have any last questions?
Thank you for the on-site and the involvement in these kind of talks. Maybe I'm far from this area, but I have one concern. I can see the necessity and the hunger for data access, but can we lead us to more defining or redefining the privacy and protections of individuals. And one of the talks that you are talking about, we need to protect the access of the data, but at the same time, we need to increase or maximize the access or the availability. And this is like against each. So how we can do this? And this is my question. Thank you.
So thank you. There is a lot of work in that because yes, there is a tension there, which we need to try and resolve. This is the sort of thing that Steve and his staff do on a daily basis. So how do you make sure that you're not sharing the data with people that you shouldn't share it with? One of the first things upstream, actually, I should have, how do you provide maximize access is respect and consent. So if the subjects involved in the research consent to have their data shared, then it's shareable. Now that may not arrive in all instances, in all areas of research. And so there are a whole load of techniques in social science data archives which allow particular protected access to the data for research purposes. And Steve has a mic, so.
Yeah, it's a very long conversation, that one that's there. My point was this is an unresolvable tension, actually, that you just have to deal with it. That it is a trade-off between the two. I know Mercedes is going to talk about differential privacy now. There are techniques for doing different things for different purposes, but the thing is, my point is there isn't an answer that says this is the right way. There is a set of trade-offs you make there, and what you need is the capacity to deal with those trade-offs fundamentally, because, if I told you there was the correct answer, then I'd be lying. It's simply a mechanism, something you have to say. The benefits to the good versus the benefits, the benefits to the collective versus the benefits to the individual is just, it just needs to be looking at the situation and understanding that that's going to be the case, and then applying the appropriate method given the problem you're trying to deal with. So I hate to say there's no right answer, but there just isn't. It's just a recognised. We have to be able to look at and understand that trade-off.
Within that constant dynamic, Merce will come in as well, but within that constant dynamic, there are things that you can do to improve and maximise access. One, for example, I showed the CARE principles earlier. In that Indigenous data government community, they're developing codes to encapsulate the concept of how the data may be shared for what purpose. And the next step is to put that into the metadata so that the data is automatically tagged and we know what we can and what we can't do with the data. So that allows the subject's preference to be carried through the data chain. Now again, that's not open all data, but at least increasing access to data for certain circumstances. Merce.
Sorry, and I know well, I'm not going to say differential privacy because I know that we can go on and talking about techniques that would help with that to lower the tension. I just want to say that this has been also used as an excuse then not to share some data that is perfectly shared, if it's aggregated, if it's anonymized, or if it's handled properly. And also that there are regulations like the General Data Protection Regulation in Europe, right, that allows us still to use data for personal data, but with the right anonymization for research. So I mean, the balance doesn't need to be all or nothing. That's all, and that's what the FAIR principles say.
And just to add, no, sorry, come in.
So yeah. So for the second part, I totally understand that we need to compromise something. But for the first part, we're related to: are we going to redefine privacy and protection of the data in order to have access to it, or not?
Well, it is a long conversation.
I mean, I would hesitate to redefine the ethical principles behind privacy, but certainly it's about maximizing in various ways, whether that's by consent, whether that's by public good, whether that's by the technical methods that I mentioned. I think I skipped over this in my presentation, but from the UNESCO recommendation, it states clearly, and I think this is extremely important, the restrictions on access should be reasonable and justified and proportionate. And it's that proportionality that Steve is alluding to. Too often, as Merce said, the idea that there might be reasons for not sharing data has been used as an excuse, quite frankly, to avoid it. Yeah. We have a question here.
Yes, thank you very much to all presenters. And I have a couple of questions, maybe for you, Stephen, at least the first one. So I was wondering about ownership, the ownership of the data, because you were talking about governance responsibilities, but I'm not sure it's the same. No, so who owns the data? No, and this is related to also to data agency, or to the fact that very often there is an unequal balance between data producers and the subjects of the data. And I'm very much in favor of bringing back this ownership to the subjects of the data. So I don't know if you could share some thoughts about this, about ownership, data agency, and governance. That would be my first question. And the second one, that is very broad, but maybe if you can share some tips, is how to integrate qualitative analysis into the quantitative for effective policies, because we are very much talking about the quantitative part. But as I said earlier, no, for many subjects, we don't have data. So qualitative insights are very important. So how can we combine both? Thank you very much.
On the first question about data ownership, I can give you well, no, it's not an easy answer, but I'll say I'll talk about the approach we take in a lot of the archives, which is we don't take ownership. What we do is we distribute on behalf of those who are the custodians of the data. So the reason I'm saying that might be seen as an easy answer is in a sense we don't make that decision. You know, the question of should subjects or researchers be the owners of data, or in fact in many legislative cases, it's actually the organisation that they work for. You know, so in the Australian case, I'm definitely aware. If you produce research at a university, you don't own the data. Your university owns the data. Yeah. So yeah. So that, you know, for government agencies, the government agency owns the data, as it were. It's I can imagine a model where subjects retain ownership to their own data, and that is the case actually with private sources. You know, so who owns the data is is an interesting case. It adds a whole nother layer of technical complexity to what we're talking about, though, when in terms of dealing, that collective individual case. It moves the power dynamic back to the individual, but it makes the collective very, very difficult as a result of that. The simplest version that I can give you is some studies have opt-in or opt-out cases, so cohort studies. So you can opt in to being a participant, or you can opt out of being a participant at the time that's there. And this has been the case in some medical studies. So it's a massive difference in the level of participation that you get from opt-in and opt-out studies. In fact, 2 big studies just didn't go ahead because they couldn't get the numbers they needed to do that. So again, there is a trade-off that's happening here. Yeah. But in this particular case, so being able to opt out is one thing, but as I say, only participating by opting in, which is it comes into consent. There are questions that are there, but some research can't be done at the level, particularly dealing actually quite often with the minority groups that you're dealing with, you were talking about before, without getting appropriate representation. So again, there's this trade-off. We just have to recognise what's there. So who owns it? You could put in a model in place there, but it actually might well be restricted to the sort of research. It might be of benefit to those you're looking to support. So that's what's there. Do you want me to cover the quality one?
I'm beginning to think we're running out of time. I can see Christopher would like a quick question, and maybe the quality one could be dealt with in
Can I give a quick 30-second answer, which is there is work being done with that Simon and I are both involved in about how do you bring qualitative data into collections. So I'm more than happy to sort of provide pointers there. Really good work in Europe, at Syracuse in the US, and a number of other places.
Yep. We're over time. We've begun to use people. So a very quick question for Christopher. That will be the last, and I'd like to make an announcement afterwards.
Okay, thank you, Simon. Oh, is it working? Yeah, it's working. So I just have a very quick comment as a young scientist, because everybody talk about a lot of things here, but from my perspective, there are several important things. And the first thing I think is representation. And for conferences like this, like the IC General Assembly, the showing and the appearance of the young scientists are really important, and make sure our voice will be heard. And the second thing, I think, like young scientists should be encouraged more to be ambitious, because the challenges facing our society will go more and more like climate change. But with the effort in the next 10 or 20 years, such that the decarbonization technology will be mature, the climate change may be solved, maybe. So I think we should really be ambitious. The support to the young scientists is really important. And thank you. And I would like to thank CODATA. Thank you, Simon and Francis. Francis, who couldn't be here, to the support, all the support I got. I could confidently showing in every conference, every occasions, and be selected as a Forbes 30 under 30 in science sector. I'm only 24. So thank you very much, and please continue to support young scientists. Thank you.
Thank you, Christopher. Okay, wonderful. Thank you very much for your participation and all the questions. We've gone over time. It feels like we haven't quite finished the questions, but I think we do have to shutter the session there. I'd like to close with, if you'd like to know more about the work that we've been doing in the World Fair project, and the continuation of that, and hear about some very specific and concrete interdisciplinary research projects that we're involved with, looking at those data challenges, as well as the other themes that have been mentioned today, then there'll be a session in the ISCGA on Wednesday morning. Please come along to that. Also, we're very keen to engage with colleagues that are members of ISC, whether that's at the national level or the international scientific unions, to increase the national membership of CODATA and to increase our collaboration with the international scientific unions. And you've heard a little bit about that already today. If you have one of these, please, there are contact details. Please do get in touch. And it's also my obligation to say that the next conference that we're organizing, in partnership with the Research Data Alliance and with the World Data System, is and with our Australian colleagues, the Australian Research Data Commons, is in Brisbane in October this year. Please pick up this leaflet and see if that might interest you and your colleagues. Thank you.